Alright guys, so welcome to our YouTube video, and in this video we will be learning about indices and standard form. And to help us with this, we will be using as our textbook of reference the New General Mathematics for Junior Secondary Schools Book 2. And this textbook is referenced in our description using the Harvard referencing style. Alright, so we'll be solving all the questions and all the exercises in the second chapter of this book, which is titled Indices and Standard Form. So as we solve the questions, we will explain various concepts and methods that will aid us in understanding the topic. Also, we'll be looking at how to round off numbers to 1, 2, 3, 4, and so on, significant figures, and 1, 2, 3, 4, and so on, decimal places. Okay, so let's get right into it. So now the first exercise is exercise 2A. Alright, and this says write out these numbers grouping digits in threes from the decimal point. To not use commas. Now we have been instructed not to use commas because that has separators while we're writing out the numbers, because commas indicates something different in some other countries. For example, like in South Africa, commas are used to write out decimal fractions. Okay, so while we use the decimal points in some other countries like South Africa and I believe Brazil, they use it as to write decimal fractions. All right, so we use spaces for this exercise instead of commas as separators. Okay, so let's go to our Microsoft whiteboard and do the questions, of course. So we're going to begin with A, which is 6 million. How do we write out 6 million? Okay, so I'm just going to write this out here. Exercise 2A, question 1. The first is A, which says 6 million. Okay, write it as this, because 1 million has 6 zeros. So this is just 6 times 1 million. Alright, that's 6 times 1, that's 6 million. So that's how I write it. Okay? And then the next one is B, which is 3,000. 3,000. Okay, now B, three thousands. Now let's understand that this is not 3. It is not 3,000. Okay, I know that some people might be confused and then say that this is 3,000, and then they might be tempted to just say that, okay, this is, I'm sorry, we're not supposed to use commas, right? But we're tempted to say that this is 3,000. Okay, no, this is thousands with a TH. So what this means is 3 over 1,000. Three over 1,000. Okay, and how do we express this as a decimal fraction? There's a trick to this. Okay, so what we simply do is that we know that this is 3 over 1,000. That's 3.0 over 1,000, and we have 3 zeros here. That's in 1,000. So what we simply do is that we move this decimal point here. That's in the 3.0. We move it 3 spaces to the left. Okay, so say we had it as this 3.0. Write as many zeros as possible. So move this decimal 3 spaces to the left. That's 1. 2, 3. So we'll stop here, right here. And this is where we'll put our new points, right here. So we say that 3 over 1000 is 0.003. Because move the 3 spaces to the left, that's 0.003. So write this as 0.003. Okay, so that's just the trick to this. We have 3 zeros, you move the decimal point 3 spaces to the left to write it in decimal fraction. Okay, so the next one is C, which says 70 millionths, right? Now, of course, this is in 70 million, so you're not going to write this as 70 million, this is 70 millionths, which means it is 70 over 1 million. Okay, so 0 cancels 0 here. So this leaves us with 70 over 100,000. Okay, now we have 5 zeros, so we're going to move the decimal points 5 spaces to the left, so that we have, now this is just for the sake of our demonstration here. Remember, write as many zeros as possible. Go 1, 2, 3, 4, 5. So move our decimal point here. So now this is 0.00007. And of course, we have to write it out within the zeros in threes. So say this is 0.000 and 07. So this is the answer. Okay. So that's it. And then the next one, which is D, 25 trillion. So how do we write 25 trillion in figures? Remember, 25 trillion is 25 times 1 trillion. And 1 trillion has 12 zeros. That's 3 zeros in 4 spaces. Okay. So it's 25. $25 trillion. Okay, so the next one, which is E, 927,066,103, just like that. And then after that we have F, okay, which is 3.6 billion. Okay, so I'm just going to erase this, or I'm just going to clear the whiteboard to give us some space. Just going to clear this here to give us some space. Okay, so that's F, 3.6 billion. It's 3 billion and 600 million. So write it out like this. That's this right here. And then next one is 740 over 100,000. So you cancel the zeros here, and then you have 74 over 10,000. Okay, so remember you move the decimal points 4 spaces to the left, right? So you have this as so 74, and a couple of zeros here. This is 1, 2, 3, 4. Stop there. So you have this as 0.0074. So answer. Right. Okay, so the next is H, just 74 over 100,000. So you move the decimal points 5 spaces to the left, okay? So this will be, so yeah, it's 0, 0, 0, zeros, and 74. Have a decimal point here. Decimal point here. 1, 2, 3, 4, 5. So right here is where we'll put our decimal points, right at 0.00007. Oh yeah, here we forgot to group it in threes. So this is 7, and then this is 4. Okay. So we do the same thing here. 3 zeros, 7, 4. Right, so the last one, no, not the last one, the ith one, just 70 hundredths. Okay, 70 hundredths is 70 over 100. 0 cancels 0 here. We have this is 0.7. Okay, remember, move the decimal point 1 space to the left, right? 0.7. Just in case you guys are confused, it's going to be 7 over 10, just 7.0 over 10. And then you had, remember, rest as many zeros as possible. 7.0, move it 1 space to the left. That's 1. 1. So we need decimal point here. So I have 0.7. Okay? And then J, just 0.8 million. 0.8 million. How do we write this out in numbers? Okay, so 0.8 is 8 over 10 times 1 million. Okay. 0 cancels 0 here. So you're left with 8 and this number of zeros, right? Which is 800,000. Okay, 800,000. So that's the answer. Okay, so now we're done with the first question. Let's move to the second question. Okay. Now, the second question says a hockey pitch measures 70 meters by 40 meters. Change the dimensions to centimeters and calculate the area of the pitch in centimeters squared. So how do we do this? Question 2. Okay, so hockey pitch. Measures 70 meters by 40 meters. Okay, so this says change the dimensions to centimeters. Alright, so first of all, we get the units of conversion. The unit of conversion is that, what's it? No, you know that 100, 1 meter, I'm sorry, is equal to 100 centimeters. Okay, so I'm just going to write this out clearly. Yeah, 1 meter equals 100 centimeters, right? So if 1 meter equals 100 centimeters, it means that 70 meters is equal to 70 times 100 centimeters, which gives us 7,000 meters, and then 40 meters equals 40 times 100 centimeters, which gives us 4,000 meters. Okay. Now, so we have our dimensions in this is centimeters. Yeah, sorry, mistake here. Centimeters. Yeah. Okay, so now the B part says calculate the area of the pitch in cm squared. Area of the pitch in squared centimeters, right? Now, of course, we know that the area should be the product of the sides, right? Of the length of the sides. So that will be 7,000 centimeters times 4,000 centimeters. This 7 times 4 gives us 28 here. And then we'll simply rewrite 3 zeros here, and then 3 zeros here. Zeros. And of course, squared centimeters. So this is the answer. So now we move to the third question. So what the third question says. Third question says, imagine you are a newspaper editor. Rewrite these headlines using a mixture of digits and words. Okay, so what this is just telling you, what this is asking you, what this question requires of you, is that you rewrite this words as though you're writing a newspaper, right? Or as though you were a journalist. Okay. So how do you write this? This says new road costs $80 million per kilometer. Okay, so how do we write this? Now we have to write this. Of course, this would appear in a newspaper in words and not in numbers like this, right? So I'm just going to draw a neat line here for question 3. Okay. So I'm going to say 3. This is A. So the way it would appear in newspaper would be new road costs $18 million per kilometer. Okay. And then B says 250,000 refugees need homes. Okay, so now if you read newspapers a lot, you know that they often wouldn't write this figure out in this manner as 250,000. What they would most likely do is to write it out as this: a quarter of a million, because a quarter of a million is equal to 250,000, right? So they'll most likely write it out as this: a quarter of a million, right? So a quarter of a million refugees need homes. Okay. C says Tycoon pays 6.5 billion for company, $6.5 billion or naira for the company. Okay, so write this as say 6.5 billion naira, or 6.5 billion or 6.5 billion naira. Both of them are correct. This one, okay, it says 1,499,516 people still without water. So how would this appear in the newspaper. Now, they will most likely do an approximation of this to the nearest second significant figure, or nearest two significant figures. So that will be 1.5 million people, right? You want to round this up to your nearest two significant figure, right? It will be 1. Okay, so you say 1.5 million people need water. I mean, still without water. Million people, or you could say 1.5 million. 1.5 million people. Okay. So let's move to the fourth question. Yeah, so the fourth question says, express 1 square meter in square millimeters. All right, how do we do this? Now let's go back to our Microsoft whiteboard. Okay, so to do this, we're just going to clear the canvas here to get some space. Okay, so question 4. It says, what does it say again? It says express, yeah. Express 1 square meter in millimeters squared, or square millimeters, square millimeters actually. Okay, so first of all, let's get the unit of conversion from meter to millimeters, and we know that 1 meter is equal to 1,000 millimeters, right? Okay. And then, so how do we get this to 1 square millimeters and 1 and millimeter squared? Okay, so we simply just square both sides. Square both sides. Okay, so we have this as 1 squared 1,000 millimeters squared, right? So this is 1 square millimeters equal to 1,000 times 1,000 square millimeters. 1 square meter equals to 1,000 times 1,000 square millimeters. Okay, and this is 1 million square millimeters. So that's the answer to the A part. The B part says the top of the matchbox measures 4 centimeters by 2.4 centimeters. Express the area of the matchbox top in square millimeters. Okay. Okay, top of the matchbox. Let's say B. Measures 4 centimeters by 2.4 centimeters. Okay, now it says, of course, express the area of the top, area of the top in square millimeters. So we could either so first of all, what we can do here is that we can convert the individual dimensions to millimeters and then multiply them. Okay, so now let's get the unit of conversion for centimeters to millimeters. So we know that 1 centimeter is equal to 10 millimeters. Okay, now if 1 centimeter makes 10 millimeters, then 4 centimeters, of course, makes 40 millimeters, and 2.4 centimeters. That's, of course, that's 4 times 10 millimeters here. Okay, and then 2.4 centimeters. It's 2.4 times 10 millimeters, which gives us 24 millimeters, right? Okay. So now let's find the area. The area, of course, will be the product of both sides, which is 40 millimeters times 24 millimeters, and that gives us 960 square millimeters. Okay, so let's see the next one. It says express the area of the matchbox top as a decimal fraction of a square meter. Okay, so how do we do this? As a decimal fraction of a square meter, right? Okay, let's go back to our Microsoft whiteboard. Okay, so I'm just gonna erase a part of this. I'm going to erase this. Sorry, I'm just gonna erase this here to make space for C. Okay, it says express the area as a fraction of square meter. Okay, or this, right? Okay. Now how do we do this? Now what we can do here is that this is the area, of course, that we're concerned with, 960 square millimeters as we go from here. So if we're going to express this as a fraction, we're going to express 960 square millimeters right here as a fraction of 1 square meter. We need to have both numbers in the same units. That is, we have them either in square millimeters or have them both either in square meters. So I'm just going to choose to put them in millimeters. Okay, and I know that from our previous calculations, I know that 1 square meter equals 1 million. This is millimeters equals 1 million square millimeters. Okay, so I'm going to say the answer, that is 960 square millimeters expressed as a fraction of a square millimeter is this in the arrow is this 960 square millimeters divided over 1 million square millimeters, right? Okay, so 0 cancels 0 here, and then remember, of course, the square millimeters both cancel out. Okay, so remember what we did in the previous question is how to locate where the decimal points will be now. Now what we have here is 96 over 100,000, right? So I have 5 zeros. Okay, let me write this out correctly. Okay, and we have the decimal point here now. Okay, so remember, all we simply have to do is to move the decimal point 5 spaces to the left, because we have 5 zeros here in 100,000. Okay, so write this up, 96.0, and then you have as many zeros as possible, so you know where your decimal point will be, and then you start counting. So it's 1, 2, 3, 4, 5. The decimal point stops here. So answer will be this, in the 0.00096. And 6. Yep. Okay, so that's it. And then over to the next question. Okay, now question 5 says, a ream of paper contains 500 sheets. The thickness of the ream is 56 millimeters. Okay, calculate the thickness of one sheet of paper. All right. Give your answers in meters as a decimal fraction. Okay, so how can we get this done? So let's write out all the information that we have. Okay, first of all, we're going to clear the whiteboard. Okay. For the whiteboard and question 5. Now, ream contains 500 sheets. Ream contains 500 sheets, and the sheets of paper. Thickness of ream is 56 millimeters. Okay, so find the thickness of one paper. Now, and okay, it also says express your answer in meters. So to get the thickness of one paper, so we're going to divide the thickness of the entire paper by the total number of sheets. Okay, so that gives us thickness of one paper. Equals 56 divided by 500, and this gives us 0.112 millimeters. Alright, so how do we get this? Of course, you know, you can use the long division. You can use the long division to get the solution, right? Sorry, just going to draw it, just give some space up for our quotient. Okay, this is sort of 500 here. We'll go 56, right? Okay, so 0 points, it says 500, we'll put 0 here. So 560 over 500, that's 1 times 500, that's 500. So we're going to put 60, right? We'll put another 0. 60 divided by 500, that's 1, right? 1 times 500, that's 500 here. And that's 100. Going to put another 0. 100 divided by 500, that's 2. 2 times 500, that's 1000. So we stop here. Okay, so this is how we got this using the long division method. Okay, so that's it, long division. All right, so I'm just going to erase this, right? This is just our rough working. Okay, so I'm just going to erase it. Okay, so that's it, 0.112 millimeters. Okay, so what next? They said express your answer in meters. Okay, so how do we do this? Now we know that 1 meter equals what? 1000 millimeters, right? So 0.112 millimeters will be equal to 0.112 divided by 1000 meters, right? Great. So remember, we move our decimal points 3 spaces to the left, just as we've been doing before in the previous examples. So we have that our answer will be 0.00112 meters. Okay. In case you guys are confused about how this was done, this is how it was done. So we have this 0.112 meters, and you want to move the decimal points 3 spaces to the left. Okay. Remember, what you do is that you write as many zeros as possible in front of the initial 0. Move the 3 spaces to the left. 1, 2, 3. So it comes here. 0.000112. That's right. So that's how we got this here. Okay, so that's it with question 5. Let's move to question 6. Okay. Question 6. Oh, so that's the end of question 1. I'm sorry. That's the end of exercise 2A. I'm sorry, that's the end of exercise 2A. We're moving to exercise 2B now. Alright, so that's the end of exercise 2A. The next is, so that's the end of exercise 2A. So we're going to move to exercise 2B now, right? Of the book. Okay. Now this says simplify the expressions by fully expanding the terms. Okay, so how do we do this? Okay, first of all, we're going to clear our whiteboard. And for our whiteboard, doing exercise 2B. It says simplify the expressions by fully expanding the terms. Okay, so following the instructions given for exercise 2B. So first we have x squared times x cubed, or x to the power of 2 times x to the power of 3. So to expand x squared here, it says x times x, that's x 2 times 1, 2, and times x cubed, x to the power of 3, so write it out 3 times. Times x, that's 1, times x, times x. Okay, that's 1, 2, 1, 2, 3. Okay, so now the solution is that we'll count all the number of x's 1, 2, 3, 4, 5. It gives us x to the power of 5. So that's the answer. And for B, it says 10 to the power of 2 times 10 to the power of 5. So same thing we did with the x's, right? So write out the 10 2 times first. That's 1, 2, and times 10, times 10, times 10, times 10, times 10 until it's 5. So that's 5. 5 here. This is 5. This is 2. Okay. And then we'll count everything together. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay. So that's x to the power, 10. I'm sorry. That's 10 to the power of 7. 10 to the power of 7. Okay. And then for C, what is C is a to the power of 4 times a to the power of 3. A to the power of 4. Okay, I'm sorry. Quality sign. So this is equal to, remember, writing out the terms fully. So we're going to write a 4 times first, right? A times a times a times a. And then we'll move over to a to the power of 3. A times a times a. And then we'll count all the a's, just like we did with the previous questions. 1, 2, 3, 4, 5, 6, 7. That's a to the power of 7. Okay. So D. Now there's actually a simpler way to do this using the laws of indices, but of course you know that learning mathematics you have to move from one step to the next step, right? So that you gain a better understanding of the concept stage by stage. Okay. So we have to get through this phase first, and then we move to, we understand certain laws of indices that will help us to solve this quicker, and would and then wouldn't have to write out all the x's or the terms fully. We wouldn't have to expand them fully. Okay, so first of all, we learn this by expanding fully, and then when we move to the next phase, we learn the easier method. Okay, so D says what now? 10 to the power of 5 times 10. Okay. Times 10. Of course, we write 10 5 times, right? Okay. Times 10. Now count everything together. That's 10 to the power of 6. And then E. 7 to the power of 5 times n times n times n times n times n times n times n, which is n to the power of 6. And then F, which is 10 to the power of 4 times 10 to the power of 5. 10 times 10 times 10 times 10. Okay, times 10 times 10 times 10 times 10 times 10. Okay, so that's what 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's 10 to the power of 9. Okay, pretty easy, right? Yeah, it is. So let's move to the next one, which is G. Okay, so we're going to need some space. We're just going to clear this. Just going to clear this canvas here. Right. So G. Now this G. That's 3a squared times 8 to the power 4. Okay. 3a to the power 2 times a to the power 4. How do we do this? That's 3 times a times a times 8 times a times a times a times a. That's writing out the a's here 4 times. Writing out the a's from this 3 squared 2 times, right? So we can collect our like terms, which is 3 and 8 first. Group 3 and 8 first here, and then write all our a's together. This first 2 a's here, first 2 a's, and then the next 4 a's. Right, so 3 times 8 is 24, and then the a's we have 6 a's, right? That's 24 times 8 to the power of 6. Okay, so next is h. So h says 5x cubed, 5x to the power of 3 times 4x to the power of 7. Okay, how do we solve this? Same thing we did with g. 5 times x times x times x, okay, times 4 times x times x times x times x times x times x. I think we have, okay, yeah, we need one more x, right? Times x. Write this out clearly. Times x. Okay. Okay, so I probably should use maybe use a different ink color when I'm writing out the x's, so that I distinguish it from the multiplication sign. Because it seems like it's a bit confusing, right? I know. So maybe I should use yellow, right, when I'm writing out the x's. Probably should do that. Okay, so I'm just gonna write this times. Okay, it's going to be some work like this. Okay, so I think we've got this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. So we've got all the x's. Okay, so we can say 5 times 4 is 20, and then since all the x's number 10, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good, so just say it's 20x to the power of 10. So that's our answer. Okay, so remember I just wrote this x's out here in yellow ink because I just thought that it would be easier to distinguish them from the multiplication signs because they kind of look like the multiplication signs, but I'm sure you guys get it. Okay, so 20x to the power of 10. Right, that's the answer. And then for I, what does I ask us? 3c squared times 2c to the power of 5. Okay, 3c squared times 2c times 2c to the power of 5. So that's, course 3 times C times C times 2 times C times C times C times C times C. Okay, of course we group the like terms and we do this again. Okay, great. So that's 3 times 2, that's 6. This is 1, 2, 3, 4, 5, 6, 7. The 6C to the power of 7. Okay, and then last one is J. So it's 4y to the power of 6 times 7y. Okay, so it's y. Oh, seems like we haven't got enough space here. So, oh yeah, we did. So 7 times y, right? That's correct. It's 4 times 7. Right, all the y's. Okay, that's 28y to the power 7. Okay, so because this is still exercise 2b, and this is question 2. So it's 2b, question 2. So like I said, this will be our first law of indices that we will learn here. Now the first question says m squared times m to the power 5. Okay, so it's m squared times m to the power 5. Now you can do this, get the answer by saying m to the power of 2 plus 5 is equal to m to the power of 7. So we're going to learn our first law of indices, right? So if you have an expression a to the power of x times a to the power of y, then the product of these two, that's a to the power of x and a to the power of y, is simply a to the power of x plus y. Okay, so this is our first law of indices that we're learning here. Okay, and that's how we got this to be m to the power of 7. So you see that this is a lot simpler and faster than having to write out the full expansion of the expression. Okay, so the next one, which is b, is a to the power of 6 times a to the power of 4. Okay, so very easy. It's a to the power of 6 plus 4, which is a to the power of 10. And then c, which is c to the power of 5 times c to the power of 9. Simply c to the power of 5 plus 9, which is c to the power of 14. And then d, which is 10 to the power of 2 times 10 to the power of 7. To the power of 2 plus 7, which is 10 to the power of 9. Okay, right. E is b to the power of 8 times b to the power of 7. Right? Yeah. Okay, so say b to the power of 8 plus 7. That's b to the power of 15. F. What is F? F is x to the power of 7 times x. That's x to the power of 7 plus 1, which is x to the power of 8. G. So to the power of 2e to the power of 4 times 5e to the power of 10. 2e to the power of 4 times 5e to the power of 10. Now imagine we had to write out this e to the power of 10. We had to fully expand this, right? That would be really cumbersome, right? That would be a lot of work. But it's a good thing that we know our first law of indices, so we can simply say it is 2 times 5 times e to the power of 4 plus 10, right? That's 10 e to the power of 14. That's 2 times 5, that's 10. 4 plus 10, that's 14. Okay, and h, which is 3 times 10 to the power of 6 times 5 times 10 to the power of 3. So say 3 times 5 times 10 to the power of 6 times 10 to the power of 3, right? Which is 15 times 10 to the power of 6 plus 3, which is 15 times 10 to the power of 9. Or we could write it out fully as 15 billion. Okay, that's h. Next is I. So what is I? I is 5y to the power of 5 times 3 to the power of 3y to the power of 3. Okay, it's 5y to the power of 5 times 3. So that's 5 times 3 times y to the power of 5 times y to the power of 3. That's 15 times y to the power of 5 plus 3. That's 15 y to the power of 8. Okay, so that's y, that's I. So that's next one is j. J is 4x times 5x to the power of 5. Like we can do j here, right? 4x times 5x to the power of 5. Okay, that's 4 times 5 times x. Now this is x here, x to the power of 1. Okay, x to the power of 1 times x to the power of 5. Okay, because x to the power of 1 is x. So say this is 4 times 5, that's 20 times x to the power of 1 plus 5. And this is 20x to the power of 6. Great. Okay, I believe that's the last one from exercise 2b. Okay, so let's move to exercise 2c. Alright guys, so moving on to exercise 2c. The first question here, the instruction says, simplify these expressions by fully expanding the terms. Now, it's just like what we did in exercise 2b, the first part, where we had to fully expand terms. Only here, what we're doing is we're dividing instead of multiplying like we did in the previous exercise. All right, so let's move over to our whiteboard to see how we can do this. Right. Okay. Okay, so we're just gonna clear this canvas. Let's get space. Yep. All right. Select our white pencil. Great. Okay. So the first one, exercise 2c. I'm gonna call this is 1, right? And is a to the power of 7. I'm sorry, this is part 1 of exercise 2a. And then the first question is a, and then it is a to the power of 7 divided by a to the power of 3. Okay, remember we're to fully expand the expression. So this gives A times A times A times A times A times A times A. That's 7 times. Then over, sorry, yeah, over A times A times A. That's 3 times. So we have that. You can just draw our brackets to just group out the A's that we're dividing. Okay, that we're gonna cancel out, right? So we have this 3 A's here. It's gonna cancel out this 3 A's here. Okay, we're just drawing a line here, cancel, and here, right? Cancels everything out. This and this. Okay, this one at the denominator, and then the 3 A's in the numerator. It's gonna cancel. They're gonna cancel each other out. Okay, so we're left with 4 A's. So we have our answer is A to the power of 4. A to the power of 4. Okay, same thing we do in the case of B. B, which is 10 to the power of 5. Divided by 10 to the power of 2. Okay, it's 10 times 10 times 10 times 10 times 10 times 10. Okay, that's 5 tens divided by 10 times 10, just like we did before. This cancels out, and this cancels out, right? So we're left with yeah. Oh, okay, seems like we wrote 6 tens instead of 5. Okay, so we're just gonna erase this one here. It's supposed to be 5, right? Not 6. This is 1 here, 2, 3, 4, 5. Yep. Okay, sorry about that. Okay, so that's 10 to the power of 3. Okay, and then C to the power of 4 divided by C. So this is C times C times C times C. That's 1, 2, 3, 4. 4 C's divided by C. So C cancels C. Left is C to the power of 3, right? And then D, which is 10 to the power of 6 divided by 10 to the power of 3. Right? Yep, 10 to the power of 6 divided by 10 to the power of 3. Okay. This gives us 10 times 10 times 10 times 10 times 10 times 10. So we just draw a line here. Okay, it's 10 times 10 times 10. Alright, so do this. This cancels out. This cancels out as well. So we're left with 3 tens. So that's 10 to the power of 3. That's the answer. Okay, so we just clear this out so we make space for the other questions. Okay, remember this is still exercise. This is still exercise 2C. Still exercise 2C. Okay, and we're doing E now, right? So E is D to the power of 6 divided by D to the power of 5. It's D times D times D times D times D times D. Right? That's 6, right? Divided by D times D times D times D times D. Okay, so we just group this here, group this here. Okay, right, and then what do? We just cancel out, right? Okay, so cancel this out, cancel this out, cancel this out. There's also 1D here, so that's D. And then for F, 10 to the power 5 divided by 10 to the power 3. That's what? 10 times 10 times 10 times 10 times 10 divided by 10 times 10 times 10. Okay, so this cancels, this cancels. So left with 2 times, that's 10 to the power 2. Okay. And for G, I think the space will be enough, so let's just do it down. Okay, let's do it down here. G is 12x, right? 12x to the power 7 divided by 4x to the power 3. Okay, so that's equal to 12 times. Okay, so we should fully expand. So we should write this as 4 times 3, right? 4 times 3 times x times x times x times x times x times x times x. So I believe that's up to 7. This is 1, 2, 3, 4, 5, 6, 7. Yeah. Divided by 4 times x times x times x. Okay, so now we could cancel this 4, cancels it here, and then we have this. We could just do a bracket here, just collect all 3's, and then all of this cancels all of this, right? So we're left with this 3 and this 4 x's, right? So that gives us 3x to the power 4. 3x to the power 4. Now next is h. Just 10a to the power 8 divided by 5a to the power 6. So how do we do this? So let's say 2 times 5, right? Times a 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 times a. Okay. This is a here. Divided by 5 times a times a times a times a times a times a. Okay, so just draw a bracket here. Just draw a bracket there and here, right? So we have 1, 2, 6 A's here and 6 A's down here. Okay. And then that's what we cancel. Right, we just cancel this because it cancels out, right? And this cancels out too. Okay, so we're left with 2 and this 2 A's right here. So that's That's equal to 2a squared, or 2a to the power of 2. Right, so the next one, which is I. Next is I, right? So I, and what does I say? I is 4x to the power of 6 divided by 4x. 4x to the power of 6 divided by 4x. How do we do this? Same as before. Okay. Okay, so I do this. Cancels. So we're left with x to the power of 5. Pretty easy, huh? Then this is 51m to the power of n divided by 3 to the power of n. Okay, so how do we do this? So of course we know that 3 times 17 equals 51, right? So we just say 17, right? Times 3 times m times m times m times m times m. We're going to write it out in 9 places. Times m times m times m. One more times m. Okay, that's correct, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Divided by 3 times m. Okay. This cancels out. This cancels out. So we're left with 17. And how many m's? That's 8 m's. So that's 17 to the power of 8. So those are the answers. So that's solutions to those questions. Pretty easy. So let's move to the second part of the exercise. Second part of the exercise, what does it ask us to do? Okay, so the second part says, simplify these expressions by subtracting the indices. Okay, so how do we do this? Pretty easy. Now, this will lead us to the second law of indices. Remember, we did the first law of indices that we use to find products. Now, we're going to use this to find quotients, like when dividing. Okay, you know, quotients is the results that you get from dividing. So we're going to use this to find, we're going to use this to help us in our division. Okay, so let's write this out now. Okay, so exercise 2C. Second part, remember, we're going to apply our new law of indices here. Divided by x to the power of 4. Now, when we're dividing with indices, all we simply need to do is subtract the powers. Okay, subtract the indices. So we have that x to the power of 6 divided by x to the power of 4 is x to the power of 6 minus 4. That's x squared. So the second law of indices is that we have a to the power of x divided by a to the power of y. The quotient will be a to the power of x minus y. So this is our second law. So our second law of indices, right? Okay. And then b. Okay, so what does b say now? B to the power of 8 divided by b to the power of 5. Okay, this is b to the power of 8 minus 5. This gives us b to the power of 3. And then c to the power of 9 divided by c to the power of 3. This is c. Can write this out clearly. C, right? C to the power of 9 minus 3, which is c to the power of 6. Okay, d is a to the power of 11 divided by a to the power of 9. This is a to the power of 11 minus 9, which is a squared to a to the power of 2. And then e, which is 10 to the power of 9 divided by 10 to the power of 7. This is 10 to the power of 9 minus 7, which is 10 to the power of 2, or 10 squared. So f is x to the power of 7 divided by x. Of course, this is x to the power of 7 minus 1, which is x to the power of 6. 6. And then g is 18x to the power of 5 divided by 9x to the power of 4. And this is 18 over 9 divided like this times x to the power of 5 over x to the power of 4. Okay, which is 2 times x to the power of 5 minus 4, which is 2 times x, or 2x, right? And then h is what now? 24x to the power of 8 divided by 6x to the power of 5. Divided by 6x to the power of 5. So of course 24 divided by 6 is 4. So, and this is 4 times, right here, I'm just going to write it out. 24 divided by 6 times x to the power of 8 divided by x to the power of 5. So this is 4 times x to the power of 8 minus 5. This is 4x to the power of 3. Then I, this is 8 times 10 to the power of 9 divided by 4 times 10 to the power of 6. Okay, so 4 here, 1, 4 and 8, that's 2 times 10 to the power of 9 minus 6, which is what now? Which is 2 times 10 to the power of 3. Okay, so this is 2 times 10 to the power of 3, or 2000. Then j, what's j now? 3.6 times 10 to the power of 7. Sorry. 3.6 times 10 to the power of 7 divided by 1.2 times 10 to the power of 3. This is 3. Okay. So clearly this is 3. So 1.2 divided by 0.6 divided by 1.2, that's 3 times 10 to the power of 7 minus 3. So that's 3 times 10 to the power of 4. Okay, so that's the second part of exercise 2C, where we learned our second law of indices, right? Yeah. Okay, this doesn't look very clear. This is 4. Yeah, 3 times 10 to the power 4. Alright, so we move to the next exercise. This exercise 2D. Okay, so exercise 2D says, simplify these expressions. Okay, so let's see how we can do that, right? It's a whiteboard. So we're going to clear the canvas so we can do our exercise 2D. Okay, so this is exercise 2D. The first question is 10 to the power minus 2. Now, in the indices, when you have any number to the power of a negative number, so you have a to the power of minus x. A to the power of minus x is the same thing as 1 over a to the power of x. Okay, so keep this in mind. Now 10 to the power of minus 2 is 1 over 10 to the power of 2, which in this case is 1 over 10 times 10, which is 1 over 100. So this is our answer. And for B, I have 10 to the power of minus 4, just as we did before the previous one. This is 1 over 10 to the power of 4, which is 1 over 10 times 10 times 10 times 10. Simply just 4 zeros. That's 1 over 10,000. Okay? Over 10,000. And C, 10 to the power of 6, minus 6, I'm sorry. So that's 1 over 10 to the power of 6, which is 1 over 1 million. Okay, for D, okay, so it's unnumbered and not method, so that's the way it is in our book of reference. So we're just going to change this to numbers. So it's 1, it's 2, it's 3. Of course, this is 4, right? So question 4 is x to the power of 5 times x to the power of minus 2. So this is x to the power of 5 times x to the power of minus 2. Okay, so let's say this is x to the power of 5 times 1 over x squared. Okay, so say this is x to the power of 5 divided by x squared, right? And this is x to the power of 5 minus 2. It's x to the power of 3, which is the answer. And then for 5, that's 5. A to the power of minus 2 times a to the power of minus 2 times a to the power of minus 3. So of course, you know this is 1 over a squared times 1 over a cubed. Or simply 1 over a squared times a cubed, which is 1 over a to the power of 2 plus 3, which is 1 over a to the power of 5, right? For 6, okay, so 6 is m to the power of 0 times m to the power of 0. Now, another thing we should know in indices is that when you have a number to the power of 0, it is 1. Okay, that's 1. So this is simply 1 times 1. So that's why it's 1. And then 7, a squared divided by a to the power of 7. Okay. Right. A squared to the power divided by a to the power of 7. Okay, this is simply a to the power of 2 minus 7. And then, of course, we know that 2 minus 7 is minus 5 or negative 5. Okay, which is equal to 1 over a to the power of 5. Right. And then for 8, x squared divided by x to the power of minus 7. This is x to the power of 2 minus 7. Okay. Just x to the power of 2 plus 7. Okay, which is x to the power of 9. Right, this might seem a little bit confusing. Okay, but we could have just done it this way, as x squared divided by 1 over x to the power of 7, right? Which is x squared times x to the power of 7. Okay. Over 1. Okay, which is x squared times x to the power of 7, which is x to the power of 2 plus 7, which is x to the power of 9. Simple like that, right? Okay, so we'll move to the next one, which is 9. But first of all, we have to clear our canvas here, right? Let's clear our canvas here. So the next one is question 9, which is 9. So let's see what 9 is. 9 is p to the power of minus 2 divided by p to the power of minus 7. Okay, this is 1 over p squared divided by 1 over p to the power of 7. This is 1 over p squared times p to the power of 7 divided by over 1. So remember, from if you're dividing fractions, right, you just invert the right hand side and change the sign to multiplication, right? So that's p to the power of 7 divided by p squared, which is p to the power of 7 minus 2, which is p to the power of 5. Alright, so 10 now. B to the power of 3 divided by B to the power of 0. So it's B to the power of 3. Okay, 11. So what's question 11? R to the power of 7 divided by R to the power of 7. Of course, that's like a no-brainer, right? Because any number divided by itself is 1. Okay. So I can easily say that this is 1. But of course, we have to show that this is, remember, this is R to the power of 7 minus 7, which is R to the power of 0, and any number to the power of 0 is 1. Okay, so that's it. 12. What is question 12? C to the power of minus 1 times C to the power of minus 1. Okay, this is 1 over C times 1 over C. which is 1 over c squared. Or we could have just said it is c to the power minus 1 plus minus 1, right? Okay, yeah, so that's it, guys, with this. This is the answer to question 12. Okay, so let's move to question 13. Okay, and there's still space here for question 13. Okay, maybe we should just write it on the difference. We should just clear the counterparts to make it neater, right? Let's say this is 13. So this is 1 over 2 to the power minus 3. Okay. So this is equal to 1 over 2 to the power 3, right? Which is equal to 1 divided by 1 over 2 to the power 3. Now, another thing with indices is that another thing that we're going to learn is that we can write this as 1 to the power of 3 over 2 to the power of 3. Okay? And then to multiply, simply invert the right hand side. 2 to the power of 3 over 1 to the power of 3. It gives us 2 to the power of 3 or 8. Also, we could have done it this way. We could have said this simply 2 to the power of minus 1 raised to the power of minus 3. And another law of indices is that in this situation, we multiply the powers. Minus 1 times minus 3. That's minus 1 times minus 3. That's 2 to the power of 3 because minus times minus is plus. So we'll have this as 8. So this might be a bit advanced for those who aren't, for those in junior secondary school class 2. So maybe you guys should just stick with this first method. Okay? But then if this is within your level of understanding, of course, by all means, you can use this. All right. I'm just going to draw a line to make it neater. And we do 14. 1 over 3 to the power of minus 2. Same as we did before. This is 1 over okay, which is equal to 1 divided by 1 over 3 squared. Which is equal to 1 divided by 1 squared over 3 squared. It's equal to 1 times 3 squared over 1 squared. Is equal to, of course, 1 squared is 1, which is equal to 3 squared, which is equal to 9. Okay, so next is 15. Question 15, which is 1 over 9 to the power of minus 1, which is Same as we've been doing before, 1 over 9 to the power of 1. This is 1 divided by 1 over 9, right? Okay, which is 1 times 9 over 1, which is 9. Okay, and we can do 16 here. Just going to draw another line. Okay, 16. So times 3a squared, so a to the power of minus 1 times 3a squared. So this is what now? 2 times 1 over a times 3 times a squared. Okay, so we can group the like terms. So times 3 is 6 times a squared over a, which is 6 times a to the power of 2 minus 1, which is 6a. Okay, so that's 16. So we have 17 and 18 left, right? Yeah. Okay, so let's see how we can do that. So we just cleared this, so we get more space. Okay, for 17 and 18. 17 is 2a to the power of minus 1 times 3a squared. Now, since this is, of course, this is a bracket here, meaning that the power of minus 1 applies to 2 and a together. So this is 1 over 2a times 3a squared. Okay, let's see, I'm sorry. We want to write this out as 3a squared over 2a. Okay, this is 3 over 2 times a squared over a. And then it's 3 over 2 times a to the power of 2 minus 1, which is 3 over 2a. That's the answer. And for 18, it's 2a to the power of minus 1 times 3a squared. Right, so now the minus 1 does not apply to the 2 because there is no brackets. So that's the difference between 17 and 18. So this is something that you should be careful about. So this is 2 times 1 over a times, remember there's a bracket, so it applies to 3 and a. So it's times 3 squared times a squared. Okay, so it's 2 times 3 squared times 1 over a times a squared. And this is what now? This is 2 times 9 times a squared over a. And this is 18 times a to the power of 2 minus 1, which is 18a. Okay, so that is those are the solutions, the answers to exercise 2D. Okay, so the next one will be exercise 2E. Okay. Alright guys, so we're going to move over to the next exercise, which is exercise 2E. Okay, and it seems like we'll be learning something new here, which is called standard form. Alright, so we're going to learn how to write numbers in standard form. We're going to learn what it is all about. So we'll begin with the first question, which is, you can first read out the instruction, which says, express these numbers in standard form. And the first question is 1, which is 9 million. Okay, so let's just go over to our Microsoft whiteboard to see how we can solve this. All right. Yep. Exercise 2E. Standard form. Okay, and now first things first. Now the standard form, also known as the scientific notation, is in this format: a times 10 to the power of n, where a is a number. A is a number between 1 and 10, and n is the exponent, or the index, or the power. So we see how we can express numbers, big numbers, and any kind of number really, in standard form. Okay, so first of all, the first question we have is 9 million, right? 9 million, that's 6 zeros. So let's see how we can express this 9 million in standard form. Now, what we want to do is to locate the decimal point. And we know for integers, the decimal point is always at the end of the number. That's the right hand side of the number, the right hand end of the number, which is this point here, right? Okay, so now what we simply do is to move this decimal points several steps to the left until we get to a point where we have a number between 1 and 10. And then the number of steps we move to the left becomes the index or the exponent in the standard form format or expression. Now let's see how we do that. So for this 9 million, we move this decimal points 1, 2, 3, 4, 5, 6. So move this 6 steps to the left, and our new decimal point will be here, right? So it means that the standard form of 9 million will be 9.0 times 10 to the power of 6, right? Because we moved 6 steps to the left, right? So it's 9.0 times 10 to the power of 6. Now, why did we stop at this point? Why did we stop at 6 steps? Now, we stopped at 6 steps because, remember, in standard form, a, which is this 9.0 here, must be a number between 1 and 10. And 9.0 or 9 is a number between 1 and 10. So 9 million expressed in standard form is 9 times 10 to the power of 6. Okay, that's simple. So let's do another question. This one is 4,000, just like we did before. This 4,000.0, we move the decimal points 1, 2, 3. This will be the new point here. So we'll say this is 4.0 times 10 to the power of 3. Remember, we moved 3 steps to the left until we got to 4.0, which is between 1 and 10. So we say that 4,000 expressed in standard form is 4 times 10 to the power of 3. Okay, so the next one is 4 billion. So how do we do this? Same as we've done with the previous ones. Point 0. So just move this 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so right here, 4.0 times 10 to the power of 9, which is 4 times 10 to the power of 9. Okay, so now that's 4, that's 600, 600.0, right? 1, 2. 6 times 10 to the power of 2, right? And question 5 is, what's question 5? Question 5 is 300,000. Okay. Just had to go back to check what question 5 was. Okay, so same as we did with the previous ones. Again, one, 2, 3, 4, 5. Okay, so 300,000 is equal to 3 times 10 to the power of 5. Alright, so moving on to question 6. Now, what is question 6? What is question 6? Question 6 is 60,000. Alright, that's 60,000. Okay, so now remember, you do not really have to show the trail of how you count or move the decimal points to the left. So I just did this for the sake of our demonstration so that you guys would follow and understand how I counted or moved my decimal points to the left. So now that once you have gotten used to it, that's probably after several examples or after attempting several questions and you've gotten used to it, you could just do this in your head, right? You could just move the decimal points in your head like this. 1, 2, 3, 4. Okay, that's 6 times 10 to the power of 4. Okay, it's faster and sort of neater, right? Okay, but of course, ensure that you have completely gotten the hang of it, right? Baby steps, of course, that you have completely gotten the hang of it, and then you're sure that you are proficient enough so that you don't need to draw the trail, and you can you're sure that you can do it in your head, work it out in your head. Okay, because it is important for you to be able to count or move the decimal points accurately, and then to get the right exponent or index in the standard form expression. So the next question is 5 billion. So just as we've done with the other ones, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 5 times 10 to the power of 9. And then 8, 17, 7 times 10 to the power of 1, or simply 7 times 10. Okay, so I think we should just clear this to make space for the next questions. Okay, so the next question is question 9, right? So I'm just going to write this, exercise 2E. Standard form. Okay, that's question 9, right? Okay. Question 9, which is 20 million. Okay, so how do we do this now? Same as we've done before. 1, 2, 3, 4, 5, 6, 7. So that's what 2 times 10 to the power 7. And question 10 is 89,000. Same as we did before. That's 8.9 times 10 to the power 4. Question 11. Remember, you count 1, 2, 3, and 4. So you stop here, and then since 8.9 is between 1 and 10. That's where you stop, right? So you put it as 8.9 times 10 to the power 4. Okay, so next one is 720 million. Same as we did before. That's 1, 2, 3, 4, 5, 6, 7, 8. So you stop here because 7.2 is between 1 and 10. So 7.2 times 10 to the power of 8. Next is question 12. That's 2,300,000. That's 1, 2, 3, 4, 5, 6. That's 2.3 times 10 to the power 6. So next is question 13, which is 55. That's 5.5 times 10 to the power 1. Simply 5.5 times 10. And 14, that's 170,000. So that's what? 1, 2, 3, 4, 5. Okay, that's 1.7 times 10 to the power 5. And 15, that's 5,400. That's 5.4 times 10 to the power 3. Oh, so after 15, you have 16. Okay, and then 16 is, well, what is 16? 16 is 25 million. Okay, so this is 2.5 times 10 to the power of 7. Remember, you move the decimal point from here 7 steps to the left until you get to 2.5, which is between 1 and 10, and then you stop, right? And then for 17, we have 6,300. Okay, and that's 6.3 times 10 to the power of 3. 18, we have 9.4 billion, or 9,400,000. I mean 400 million. So this is 9.4 times 10 to the power of 9. For 19, we have 410,000. This is 4.1 times 10 to the power of 5. For 20, that's 85 million. Okay, so that is what? 8.5 times 10 to the power of 7, just like we did with the other ones. Move the decimal points to the left until it gets to a number between 1 and 10. For 21, $9.15. That's what? 9.5 times 10 to the power of 2, right? From here, 1, 1, 2, right? Okay, just do that for the sake of our demonstration, just to ensure that you guys are still following. For 22, that's 3,600, right? So that's what? 3.6 times 10 to the power of 3. For 23, that's what? 360. 3.6 times 10 to the power of what? 2. 1, 2. Okay. For 24, that's 36. So it goes 1. That's 3.6 times 10 over 1. Or simply 3.6 times 10. Okay, so that's it for exercise 2E. Let's see what exercise 2F is about. Alright, so exercise 2F says, change these numbers from standard form to ordinary form. Okay, so basically what we're required to do here is the reverse of what we've just learned, to change from standard form to ordinary form. Okay, so let's see how we can do that. Let's go back to our Microsoft whiteboard. Let's see how we can change from standard form to ordinary form. Okay, so I'm just going to clear this to make space for new exercise. Now we'll see how we can solve the questions here in exercise 2F. Change from standard form to ordinary form. Okay, so the first one is six times 10 to the power 4. Okay, so now remember in the first in the previous exercise we changed from ordinary form to standard form. Okay, now we're changing from standard form to ordinary form. So really what we're doing is a reverse process. So to do this, what we first have to do is to locate where the decimal point is in this part of the standard form expression. Now that is where we have 6 here. So now this can also be written as 6.0 times 10 to the power 4. So you know that the decimal point is here. Okay, now remember this is a positive index, which is 4, right? Meaning that the number from which this was changed to standard form is an integer. Okay, so you have a positive index in the standard form expression. It means that the number from this which this standard form expression was gotten is an integer. Okay, so how do we change this to ordinary form? So you simply write as many zeros as possible, right, after the decimal point, and then you move the decimal points 4 spaces to the right this way, okay, because we have the index as 4. That's 1, 2, 3, 4. And then you stop here, which is where your new decimal points will be. Okay, so if we do that, we'll have 0, 0, 0, 0, and 6. Of course, your new decimal points is here, and say 0.0 here. Meaning that the ordinary form of this standard form expression, 6 times 10 to the power of 4, is 60,000. Okay, let's do the second question, which is 8 times 10 to the power of 3. Pretty much the same thing we did in the previous one. 8.0 times 10 to the power of 3. I'm just going to write this out clearly. Okay, again, this is just a trick you use. You just go 1, 2, 3. Stops here, right? So that's what? 8,000. So there you go. Your answer is 8,000. And then for 3, you have 9 times 10 to the power of 5. So how do you do this? Remember, this is 9.0 times 10 to the power of 5. you go 1, 2, 3, 4, 5. Okay, so you have this is what 9, 0, 0, 0, 0. That's what 900,000. Okay, so you see it's just the reverse process. So when we're changing to standard form, because it was an integer, we had to move. For example, if we were to change this 60,000 to standard form, knowing that the decimal point, of course, is here, we move 4 spaces to the left, right? 1, 2, 1, 2, 3, 4. So we have it as 6 times 10 to the power 4, right? But then in changing to from the standard form to the ordinary form, we simply did the reverse. We moved the decimal point from here 4 steps back to the right to get the original number that's in the number in ordinary form. So we can see it's just the reverse of what we did in changing to standard form. Okay, and that's what we do for the other questions. So let's move on. So the trick is to do as many questions as possible, just so you get the hang of it and you get used to it. That's 4.0 times 10 to the power of 2. Just 1, 2, right? So that's 400. And then 5. Question 5 is 7 times 10 to the power of 1. How do we do this? 7.0 times 10, right? 1 decimal points here. So that's 17, right? Okay, and then for 6, question 6 is 3 times 10 to the power of 2. Okay, so we simply just, first of all, you locate where the decimal point is. That's 3.0 times 10 to the power of 2. And then you move it 2 steps to the right here. That's 1, 2. Okay? So that's what 300. And then for 7, that's 5 times 10 to the power of 7. Same as we did with the previous questions. From 0, write as many zeros as possible to a reasonable extent. Then move the decimal points 1, 2, 3, 4, 5, 6, 7. Stop right here. So you have this, just write the number of 0, 0, 0, 0, 0, 0, 0. That's 1, 2, 3, 4, 5, 6, 7. That's 1, 2, 3, 4, 5, 6, 7. Good. So how do you group it? So you start from the right, grouping the digits in threes. And then this, that's what 50 million. 50 million. And then with 8, what is question 8? Now what is question 8? Question 8 is 2 times 10 to the power of 6. That's 2.0 times 10 to the power of 6. So how do we do this? Same as we did with the previous questions. Go 1, 2, 3, 4, 5, 6. Okay, so you stop here. And go 2, 0, 0, 0, 0, 0, 0. So how do we group this? Remember, start with grouping the zeros in threes. And then 2, so that's 2 million. Okay, so we do the next question, which is question 9. Just going to clear the canvas to create more space. So I'm going to write exercise 2F standard form to ordinary form. So there's a continuation, right? So question 9 is 6 times 10 to the power of 8. Okay. So remember, you can write as many zeros as possible. Okay, just enough zeros so that you're able to conveniently place your decimal points when you're counting. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8. So put your point here, and then 6 times 10 to the power of 8 in ordinary form is what? So you just write this, can we do this first, grouping your zeros in threes, 0, 0, and then 0, 0, 6. That's 600 million. And 10, question 10 is 6.3 times 10 to the power of 4. Okay, so here we already know where the decimal point is, right? So we just write this, as many zeros, and then we go 1, 2, 3, 4. So how many decimal points can be here, right? So that's what now? 63,000. And 11, that's 8.4 times 10 to the power of 3. That's 8.4, 0, 0, 0, 0, 0. Note the decimal, 1, 2, 3. Stops here. So that's 8,400. Okay, and 12. We have 9.8 times 10 to the power of minus 5, or negative 5. Same as we did before. Put as many zeros as you can. Go 1, 2, 3, 4, 5. Stop here. And this is what? 980,000. Okay, simply just writing it down. 99880000000. Yeah. And then stop, of course, right? And then for 13 is 7.2 times 10 to the power of 1, which is what? 1. Just one step. So you have that this is 72. And then for 14, it's 3.6 times 10 to the power of 2. So you just do this. 3.6, we go 1, 2, stop here. that's 360. And then for 15, it's 4.4 times 10 to the power 2. Go 1, 2, 3. I'm sorry, we're counting 2 steps. We're counting 2 steps, so go 4.4. So go 1, 2, right? Stop here. So that's 14. And then for 16, 5.1 times 10 to the power 7. I'm going to go 5.1, 0, 0, 0, 0. Go 0, 0. As many zeros as possible. I go 1. So it says, well, let me strike clearly. Okay, so we go 1, 2, 3, 4, 5, 6, 7. Right? So that's what now. That's 51 million. Okay, so I'll just clear this to make space for the next questions. So next is 17. Next question is 17, and it's 2.5 times 10 to the power 6. How do you write this down? That's 2.5, 0, 0, 0, 0. Go like this: 1, 2, 3, 4, 5, 6. Stop here. Okay, that says what now? That's 2,500,000. So 18, 6.7 times 10 to the power 8. So how do we do this? So go 1, 2, 3, 4, 5, 6, 7, 8. Stop here. And that's what now? That's 670 million. Next is 3.7 times 10 to the power 3. Okay. It's 1, 2, 3. Stop here. That's 3,700. And 20 is 5.9 times 10 to the power 7. Okay, so how do we do this? So go 1, 2, 3, 4, 5, 6, 7. Stop here. This 1 point here. Right. So that's what 5. Right. That's 59 million. I'm just gonna write this in 9 clearly. Okay, 21. 8.5 times 10 to the power of 4. Okay, that is so go 1, 2, 3, 4. So that's 85,022. That's 3.4 times 10 to the power of 3. So 1, 2, 3. Stop here. That's what? 3,423. 3.4 times 10 to the power of 2. That's 3.4, sorry. Add your zeros. So move 1, 2, stop here. And that's 314. And then 24 is 3.4 times 10 to the power of 1. Go 1, stop here. That's what? 34. Okay, so guys, that's it. How to do the reverse process of changing from standard form to ordinary form. So remember, this is the positive index, and changing from standard form to ordinary form, we move the decimal points to the right because this is a positive index, and you will soon see that if the index were negative, we would have done something different. Instead of counting to the right, we would count to the left and move the decimal point to the left. We will see that in the next exercises. Okay. Alright, so we're done with exercise 2F, and we have seen how to write numbers from standard form to ordinary form, how to go from the standard form to the ordinary form. So now we learn something new, not entirely new, but just a different angle from what we've been doing before. So now we're going to learn how to express decimal fractions in standard form. So we'll be doing all the questions in exercise 2G. So we demonstrate how it is done. Alright guys, so we're here in our whiteboard, and we're going to be doing all the questions in exercise 2G, but we'll see how we can convert decimal fractions to standard form. So our first question is 0.005. So how can we write this in standard form? Pretty easy. Okay, so remember, we have to move the decimal point to a number that is between, until we get to a number that is between 1 and 10 to form the A part of our standard format, right? Of the standard form or scientific. Notation, right? Remember, A has to be a number between 1 and 10, and N is the number of steps you move the decimal point until you get there. Okay. So how do we do this? Simple. I'll just rewrite it again for the sake of my demonstration. So I'm going to move decimal points 1, 2, 3. So this is a number between 5.0, actually is a number between 1 and 10. I'm going to stop here and put my decimal point here. Right? 5.0. And then how many steps did I move? I moved 3 steps. So it's going to be 5.0 times 10 to the power of minus 3. Now why is it minus 3? It is minus 3 because this is a decimal fraction, and this simply means 5 over 1,000, or 5 over 10 to the power of 3. And we know from our laws of indices that this is the same thing as 5 times 10 to the power of minus 3, right? So that is why in decimal fractions, when you move the decimal point until the point where you have a number between 1 and 10, the index and the standard form expression will be negative. Okay, so let's look at the second question, which is 0.08. So how do we do this? Same as we did in the previous question. 1, 2. We're stopping here because 8, of course, is between 1 and 10. So the answer is 8 times 10 to the power of minus 2. Okay, so question 3, 0.0006. Same thing we've been doing, same thing we did with the first two questions. 1, 2, 3, 4. Stop here. That's 6 times 10 to the power of minus 4. Okay, it's quite easy, right? And then 4, 0.00004. Again, 1, 2, 3, 4, 5, 6. That's 1, 2, 3, 4, 5, 6. You stop here because 4 is between 1 and 10. So that's 4 times 10 to the power of minus 6. And for 5, it was 0.0002. Remember, your aim, what you want to do is that you want to move the decimal point until you get to a number that is between 1 and 10, right? So some of you might ask, or you might be curious, and you could just say, why can't we move the decimal points this way? You can't move the decimal point this way because if you continue moving the decimal point this way, you would never get to a number between 1 and 10. So you move the decimal point in this direction, right? So that you get to a number that is between 1 and 10. Just in case anyone was wondering why we didn't move the decimal points the other way. Okay, just thought to put that in. All right, so let's continue. This is 0.0002, right? We move on decimal points 1, 2, 3, 4, 5. Stop here. And that's 2 times 10 to the power of minus 5. And then for 6 is 0.00009. I'm sorry, that's another 0 before 9. Alright. Question 6. Yeah, that's another 0 then. Okay. Let's write this out clearly. Okay, so 1, 2, 3, 4, 5, 6, 7. Right? So that's what 9 times 10 to the power of minus 7. Okay, so question 7, which is 0.3, says 3. Okay, sorry, this is gonna write itself again, right? So as we did with the previous one, 0.3. So you move the decimal points here, one step here, and that's what 3 times 10 to the power of minus 1. Okay, and 8, 0.003. You go 1, 2, 3. Stop here. Alright, so that's 3 times 10 to the power minus 3. And then for 9, 0.0003. You 1, 2, 3, 4, 5. Stop here. That's 3 times 10 to the power minus 5. And then for question 10 is 0.038. Okay, 0.38. So 1 equal 1, 2. 3.8 times 10 to the power minus 2. Okay, so let's clear the canvas so we make space for the next questions. Alright, question 11. 0.062. One, 2, 3. That's 6.2 times 10 to the power minus 3. 12. 0.71. It's 1 here. So 7.1 times 10 to the power minus 1. 13. 0.008. 8. Make sure I'm correct. 13, yeah, 0.00088. Okay, so 1, 2, 3, 4. That's 8.8 times 10 to the power minus 4. And 14 is 0.0045. So that's 1, 2, 3, 4. That's 4.5 times 10 to the power minus 4. And for 15, 0.00026. So it goes 1, 2, 3, 4, 5. Stop here because 2.6 is between 1 and 10. So it's 2.6 times 10 to the power minus 5. And then for 16, it's 0.000072. So it goes 1, 2, 3, 4, 5. Right? So that's 7.2 times 10 to the power minus 5. And for 17, 0.0000055. Okay, just rewrite this, right? And then move our decimal points. 1, 2, 3, 4, 5, 6. Or 6, okay. 18 now. 0.011. That's 1, 2, right? So that's 1.1 times 10 to the power minus 2. For 19, 0.000000091. So go 1, 2, 3, 4, 5, 6, 7. Okay, so that's 9.1 times 10 to the power of minus 7. 20. And then 0, 0, 0, 0, 0, 0, 6, 7. That's 1, 2, 3, 4, 5, 6, 7, 8. So here, that's 6.7 times 10 to the power of minus 8. 21 is 0.0057. So it goes like this: 1, 2, 3, stop here. And that's 5.7 times 10 to the power of minus 3. Okay, so the next is 22, right? That's 0.00015. That's 1, 1, 2, 3, 4. So that's 1.5 times 10 to the power of minus 4. Okay, so we have 2 more questions, 23 and 24. So we'll just clear the canvas and make space for them. Okay, so 24. Of course, this is still exercise 2. Exercise 2G, right? So 23. And 0.00015. All right. So go 1, 1, 2, 3, 4. That's 1.5 times 10 to the power of minus 4. For 24, that's 0.015. That's 1, 2. So that's 1.5 times 10 to the power of minus 2. Okay, so that's all with exercise 2G. So now we have learned how to change these decimal fractions such as these to standard form. Saying that if we move the decimal points here to the right as we did here, we make the index negative, and then of course we must move the decimal points until we get to a number that is between 1 and 10. Okay, so let's see the next exercise. See the next exercise and you know what to do. Alright, so the next exercise is exercise 2H, where it says express these numbers as decimal fraction. Okay, express these numbers as decimal fraction. Right, so question 1 is 2 times 10 to the power of minus 4. Okay, so how do we do this? So first of all, we locate where the decimal point is, and of course this is 2.0 times 10 to the power minus 4. So how do we do this? Now write this 2.0. Of course we can write as many zeros as we like in front of the 2, and then we'll move our decimal points to this side, right? 1, 2, 3, 4. I'm stop here. 0.0002. So this is the answer. Then for 2, 8 times 10 to the power minus 6. Locate your decimal points, and then you write as many zeros as you like to a reasonable extent, just so you are able to place the decimal points the number of times according to the index. Okay, so you go 1, 2, 3, 4, 5, 6. This decimal point here. So it's equal to 0.000008. So now we're question 3. This is 5 times 10 to the power minus 3. Question A is 5.0 times 10 to the power minus 3. So how do we do this? Same as we did with the previous ones. 0.0. Now you move the decimal point to the left 3 times, right? Because the index is 3. Go 1, 2, 3. You stop here. This is 0.005. Okay, 4. This is 4 times 10 to the power minus 2. We go 1, 2. Stop here. That's 0.04. Okay, 5. 5 is 7 times 10 to the power minus 1. Okay. Remember, it doesn't matter the number of zeros you write before the 7 here. You can write as many zeros as possible, but just do it to a reasonable extent so you're able to count or move your decimal points the right number of steps according to the index. So we just move this 1 step back here, 1 step to the left. So we have this as what, 0.7. And then for question 6, we have 3 times 10 to the power minus 5. Am I correct? Question 6. Yep, that's 3 times 10 to the power minus 5. So go 1, 2, 3, 4, 5. Stop here. 0.00003. Of course, there's this 0 here, this one 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 here. Okay, 7. You have 6 times 10 to the power minus 3. So move your decimal 1, 2, 3. Stop here. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 0.006. 8 now. And so 1, 2, 3, 4, 5. Okay, so that's what 0.00009. Okay, so I hope we're getting the hang of it. So we move to question 10. We just clear the canvas to make more space. I'm just gonna write this out again. Exercise 2H. Question 10. Question 10 is 2.8 times 10 to the power of minus 4. So we'll know where the decimal point is already here. Alright, so we just put all zeros and 2.8. I'll just move this 1, 2, 3, 4. So stop right here. So it's a 0.00028, like that. And then 11 0.3 times 10 to the power of minus 6. We know what the decimal point is already, so we just write all zeros. 8, 3 decimal points here, so we say 1, 2, 3, 4, 5, 6. Stop here. So that's 0.0000008 and 3. For 12, you have 5.1 times 10 to the power of minus 3. So you move the decimal point from here. 1, 2, 3. Stop here. So that's what now? 0.0051. $13. 4.5 times 10 to the power minus 2. So that's 0.0000045. Remember, write as many zeros as possible. So you start from here. 1, 2. The decimal point was initially. That's here. 1, 2. So stop here. And that's 0.045. Alright, so this 0 comes here, this 0 comes here, this one comes here, this one comes here. All these other zeros are irrelevant. Okay. And then 14 is 7.9 times 10 to the power of minus 1. So you go 1, just one step. Stop here. And 0.79. And 15 is 3.3 times 10 to the power of minus 5. So you go 1, 2, 3, 4, 5. Stop here. So you have it as 0.0000033. Okay. And 16. 6.2 times 10 to the power of minus 3. So you have this as 0.0000062. 2. Alright, there's 1 point here. So you go 1, 2, 3. Stop here. So that's this 0 points, this 1, 0, this 0, 6, and 2. And for 17, 9.4 times 10 to the power minus 5. Okay, so how do we do this? 0, 0, 0, 0, 0, 0, 9, 4, no decimal points here, right? So you go 1, 2, 3, 4, 5, stop here, 0 points, 0, 0, 0, 0, 9, 4, that's 18 now. 18 is 2.6 times 10 to the power minus 4. That's so go 1, 2, 3, 4, stop here. 0 points, 0, 0, 0, 2, 6. Okay. Next is 19. 19 is 1.8 times 10 to the power minus 1. So you go from there, 1, right? Just one step. That's 0 points. There's 1 point here, that's 0 points. 1, 8. 1, 8. For 20, so 8.8 times 10 to the power of minus 3. Okay. So same as we've been doing before. 8.8. That's 1, 2, 3. Stop here. 0.008. 8. For 21, that's 4.1 times 10 to the power of minus 2. So your answer is 0, 0, 0, 0, 4, 1. That's 1, so you go this, like this, 1, 2, you stop here. Now 0 is 0 points, and 0 here, and 4, and 1. Okay, so let's move to let's do the last 3 questions. That's 22 to 24. Alright. Exercise 2H. 22. One, 2, 3. Stop here. 0.0024. And for 23, we have 2.4 times 10 to the power minus 2. Same with this, 1, 2, stops here. And 0.024, right? For 24, that's 2.4 times 10 to the power minus 1. So we go like this. That's 1 point here, 1. That's here. 0.24. This 0 is here, this 2 is here, this 4 is here. Okay, so that's it, guys, with changing standard form expressions with negative indices to decimal fractions. So now when you see that the index is negative, you move the decimal point to the left. Okay, the number of times as indicated in the exponent or the index or the power. Okay, so the trick is, of course, to do as many questions as possible so that you get the hang of it and you get used to it. Right, so let's see what the next exercise is about. So we go to, slides, see what the next exercise is about. Okay, now this is different from standard form. Okay, this one says, this is exercise 2i. It says, round up these numbers to the nearest 1,000, 100, and 10. Okay, so how do we do this to nearest 1,000? Right, so let's go back to our whiteboard. Okay, I'm just going to clear the canvas. Okay, new exercise. So that's 2i. Round enough numbers to the nearest, 1,000, and 200, and 10. Okay, so of course the first question is question 1, which is 12,835. Okay, so how do we do this? Now what we want to do is that we must keep this in mind. So this first part here represents thousands, this hundreds, this 100, this is 10, and this is units. Okay. Starting from the left, 1,000, 100, 10, units. So the nearest 1,000 will be this, 100 will be this, 10 will be this, and units will be this. Okay. So how do we round up to the nearest 1,000? Now the rule is you round up numbers between 5 and 9. Round up numbers between 5 and 9, 5 and 9 inclusive, and then you round down numbers between 1 and 4, 1 and 4 inclusive. Okay, so let's see how we can solve the first question. Okay, question 1. 12,835. So now to the nearest thousand, starting from the left, of course, since this 1,000 here is, of course, 1, 2, right? So now the next number that is closest to our 1,000 part of the figure is 8. And then since 8 is a number between 5 and 9, we have to round up. So we transfer 1 from 8 here to this 2. We add 1 from 8 to 2 to make it 3, right? Okay, so we say that this is 13,000, and 8 becomes 0, 3 becomes 0, and this becomes 0. Then for 100, so this is the I part. So nearest 100. The nearest 100 here is what? 8, right? So it's going to be 12. And then since the number after 8 is not between 5 and 9, we have to round down. And we can't add any 1 from 3 to 8 because it is not between 5 and 9. So we say 12, 8, 0, 0. Okay. And then nearest 10, now the 10 here is, the 10 digits here is 3, okay? And then we have 5 here. 5 is between 5 and 9, right? So we take 1 from 5, add it to 3, and then round 5 to 0, round 5 down to 0. So we have this as 12,814. Okay, that's for question 1. Question 2. It's 46,923. Now remember 1,000 here, right? $46,000. So the 1,000 is here, right? Okay. And then the next digits after 6 is what? 9. And 9 is between 5 and 9, right? So we take 1 from 9, add it to 6 to make it 7, and then we round down 9, 2, and 3. Okay, so that's 47,000. Okay, so this is I. For 2, that's so the 100 part is what? The 100 part is 9. Now 2 isn't between 5 and 9, it's between 1 and 4. So we have to round this down, and we cannot take any 1 from 2 to add to 9. So it's going to be 46,900. Okay. And then the third one, to the nearest 10, says 3. So the 10 digits is here to here. Okay. And then the 3, the digits after it, which is 3, is between 1 and 4. So it means that we cannot add any 1 from 3 to this point here. So what we do is that we round this down to 0, and then we write it as 46,920. Okay, so we'll do the third one. Third is 28,000 for C. C is 28,006. Okay, so letters were used, so just this is letters A, B, and C. So I 28,006. Remember this to the nearest thousand. That's 8 here, 28,000. Of course, we can't do anything about the 0 here, which is next to 8, because we can't add 1 from it. So we just write this as 28,006. I mean 28,000. And 2 nearest 100, that is this here. So it's going to be 28,000. And 3 nearest 10, which is this here, counting from going from the left, right? It's going to be 28,010, because this is between 5 and 9. So we'll take 1 from 6 to this point. I'll round this down to 0, so it's 28,010. Okay, so now going about this again, 1,110 units. Okay, now the trick here is for numbers between 5 and 9, okay, you take 1 from those numbers, add it to the digits that you're concerned with, because we're concerned with thousands here. So we took 1 from 8 because it's between 5 and 9, and then we added it to 2. This gave us 3, and then we rounded off the rest of them. Okay, for 12,835, we're concerned with we started from left. You always start from the left, right? From your left to the right in this case, right? So we're concerned with 8, which is 100, right? So the digit next to 8 is 3. 3 is not between 5 and 9, so we can't add 1 from 3 to 8. So we'll simply just round 3 down and the other number, or the other digits after it. And then with this one, we're concerned with 3 because this is 10. 5 is between 5 and 9, so we take 1 from 5 to make it, to add to 3 here to make it 4, and then we round this down to 12,814. Okay, so this is to the nearest 1,000. This is to the nearest 1,000. This is to the nearest 100. This is to the nearest 10. Okay, so that's let's clear the canvas to make space for the next questions. So now we continue with exercise 2I, and the instruction is the same, round off. To the nearest 1,000. To the nearest 100, and nearest 10. Okay, so next is D, and that's 9785. So to nearest 1,000, of course, the 1,000 digits is right here. So you start from left Alright, start from the left. Next digit after it is 7. 7 is between 5 and 9. So take 1 from 7, add it to 9 to make it 10, and then the rest round up to 0. This has 10,000. Then 9785. 100 is here, 9,785. So 100 is at 7. So how do we do that? Next digit after 7 is 8. 8 is between 5 and 9. So we take 1 from 8, add it to 7. So it becomes 9,800. So the nearest 100. Okay, and then 10 is here. And 10 is over 8. This is unit. So 10 is here, right? So that's what. Next digit after 8 is 5. I remember 5 is between 5 and 9. So we'll take 1 from 5. We're going to round up. We'll take 1 from 5, add it to 8, and then this becomes 0. So it's 9790. Okay. Next is B. That's 30,637. Remember, this is 1,000, 100, 10 in units, right? So to the nearest 1,000, remember the 6 after the 1,000 parts is between 5 and 9. So what do? We round up. So we take 1 from 6, add it to 13, that's 31, and then it becomes 0, 0, right? Rest becomes 0. And then for the second one, to your nearest 100, remember the 100 is here. So we say, and then this 3 is what is not between 5 and 9, it's between 1 and 4. So we have to round down. So we'll say this is 30,600. Okay. And this is 30,637. I have your 10 here. So to the nearest 10, it's going to be 30,640. Why? Because 7 is between 5 and 9. 7 that is next to the 10 digits is between 5 and 9, right? So we take 1 from 7, add it to 3, 3 becomes 4, and this is 0. Okay. F, that's 13,067. Remember, this is 1,000, 100, 10, and units, right? So to the nearest 1,000, after 13, the digits is 0. 0 is not between 5 and 9. Okay, so we cannot round up. So we simply write this as 13,000. Okay. And then for the nearest 100, 13,067. 100 is here. Next digit to it is 6. 6 is between 5 and 9. So we take 1 from 6, add it to this. It becomes 1, and then every other thing becomes 0. Next is 13,067. So this is 10 here. Okay, so 7 is between 5 and 9. So we take 1 from 7, add it to 6, so it becomes 7, it becomes 0. Okay, so maybe we should just draw a neat line. So we can do the other questions. So now it's G. So let's see what G is. G is 8,615. Remember, this is 1,000, 100, 10 units. Okay, so 3 nearest 1,000 for 8. Now the digit after 8 is 6. 6 is between 5 and 9. So we take 1 from 6, add it to 8, becomes 9. And the rest of it becomes 0. And for 2, which is to the nearest 100, 100 is here. Now the digit after the 100 place is 1. 1 is between 1 and 4, so we cannot round up, meaning that we cannot add 1 to 6. So we round down and we say 8,615 to the nearest 100 is 8,600. Okay, to the nearest 10. This is 10 here. How do we do this? Now, 5 is between 5 and 9. So we simply take 1 from 5, add it to 1 here. So it becomes 8,620 to the nearest 10. And next question is H. 4517. I'm going to try to element B. Okay, so it's your nearest 1,000. So 5 is between 5 and 9. So we'll take 1 from 5, add it to 4, becomes 5,000. So your nearest 100, I have 100 here, and the digit next to the 100 place is 1. It's not between 5 and 9, so we have to round down, right? And then this becomes 0 after a round down. So and we cannot add 1 to 5 because this is not between 5 and 9. So it becomes 4,500. And then 4517. This is our 10 here. So this becomes 4,520, because 7 is between 5 and 9. So you take 1 from 7, add it to this 1 here, becomes 2, and this goes to 0. Then the ith question is 16,516. This is 1,000, 110 units. Okay, so for I, remember 5 is between 5 and 9, so you add 1 to 1,000 here, that's to 16 here, that's 17. There's the 0. And for 2, so you take 1 from 6, add it to this one here, comes 16,600. Okay, and then there's around 10 here. 0, of course, is not between 5 and 9, so you cannot round up. So it's going to be 16, 5, 16 to the nearest 10. Okay, so I believe we have how many more questions? We have 3 more questions, K to L. So we're going to need some more space here. So I'm just going to clear this. Exercise 2I. Round off to the nearest 1,000 to 100 and 3, 10. So next is J, right? So J, and J is 59,094. So this is 1,110 units. So how do we do this? So to nearest 1,000, this here, this is the 1,000 place, this is the 1,000 place here. And then the digits after the 1,000 place is 0. 0 is not between 5 and 9, so we cannot round up. And we cannot add 1 from this, from 0 to this. So write this as 59,000 to nearest 1,000. That's the answer. So for 100, 59,094. This is our 100 place here. Now the digit after the 100 place is 9. And of course 9 is between 5 and 9. So we round up, right? Add 1 to 0, and then the rest becomes 0. And then to the nearest 10, this is our 10 here, right? So 4, of course, is not between 5 and 9. So we cannot add 1 to 9, so we leave it as it is. And then, of course, this 4 becomes 0, we round down. Then K is 5,555. Okay, so this is 1,110 units. Okay, so the digits after the 1,000 place is 5. 5 is between 5 and 9. So add 1 from 5 to this, so it becomes 6,000. And then for 2, hundred here. So add 1 from 5 to this, it becomes 5,600. And for 5, 10 is here. So add 1 from 5 here, which is the digit next to it, because it's between 5 and 9. So you have 5, 5, 6, 0. Okay, then the last one, L. L is 19,503. Okay, remember going from left to right, yeah? 6,000, 110, right? Okay, so since 5, which is the digits at the 1,000 place, is between 5 and 9, we round up, so we add 1 to 19, becomes 20, and of course the rest becomes 0, it's 20,000. So the nearest 100, of course 0 after the 100 place is not between 5 and 9, so we cannot round up, so it's 19,500, and then that's just 2, and then for 3, it's just 10, right? 3 is not between 5 and 9, so we cannot round up, so we leave it as this, 19,500 again. Okay, so I hope you guys got the hang of it. Remember, I'm gonna write this clearly. So remember, rounding up integers like this, or numbers like this, you count from left to right, okay? And then for numbers between 5 and 9, you round up. For numbers between 1 and 4, round down. Okay, so that's it with rounding off numbers for exercise 2i. Let's move to the next exercise. So exercise 2i still continues, and this time it says round up these numbers to the nearest whole number, 10th and 100th. Okay, so let's see how we can work this. Alright, let's go back to our whiteboard. So we just clear the canvas. So it's exercise 2i. Okay, for the second part. So round off these numbers to nearest whole number, to nearest 10th and to the nearest hundredth. Okay, so let's learn how we can do this. So the first question is 2.517, and then this is a 2.517. Okay, so this, I'm going to use this fraction as an example. So this one here, this 2 here, is the whole number part. This 5 here is the 10th part. 1 is the 100th part here. Okay, 10th, 100th. Okay. So let's work the first question. Let's work out the first question. That's 2.517 to your nearest whole number. Okay, remember we're going from left to right. And then since 5 is between 5 and 9, so we add 1 from 5 to 2 comes 3. So your nearest whole number, it is 3. And then for 2, nearest 10th, let's say the 10th here is 5. And then 1 after 5 is not between 5 and 9. So we cannot add 1 to any 1 to 5. So we say it's 2.5. 2.5, right? And then for the third one, so nearest 100th. So we see that 7 after the 100th place is between 5 and 9. So we add 1 from 7 to 1 here. So it makes it 2.5. And then the B question, question B, that's 7.994. Number 7 here is a whole number. And after 7 is 9. 9 is between 5 and 9, of course. So the digit 9, take 1 from 9 here to make this 8. So nearest whole number. So the nearest 10th place is this, right? 7.994. This is the 10th place here. And then 9, of course, is between 5 and 9. So we take 1 from 9 here, add it to this, it becomes 10. So this also becomes what? 7 plus 1 becomes 8.0, because this is 10. So you might have been tempted to say that since this is 10, maybe we should just write it as 7.10. No, that would be wrong. This is 10 actually. When you say 1 plus 9 is 10, so you have to add the 1 to 7 here, right, to make it 8.0. Okay, not 7.10. Alright. And then for the third one, to nearest 100. This is the 100th place here. And then 4 is not between 5 and 9, so we cannot round up. So it is 7.99. Okay. So I'm just going to draw a line here for the other questions. So for C, 3.125. So the whole number part here is 3, and then after 3 comes 1, and then since 1 is not between 5 and 9, simply say the whole number part is 3. I mean the nearest whole number, 3.15 to nearest whole number is 3. And then for 2, the 10th part, so I'm just going right out here, it's th, 10th part here is 1. And number, the digit after it, which is 2, is not between 5 and 9. So say this is 3.1. And then to nearest 100th. So 5 is between 5 and 9, so we can take 1 from 5, add it to this to become 3. So to nearest 100 is just 3.13. For D, (0.945). For I, this is the whole number part here. 9 is between 5 and 9, so take 1 from 9 here. So that's 1. Okay. And then for the second one, to nearest 10th part is this, right? So 4 is not up to 5, it's not between 5 and 9, so we cannot add 1 to 9 here, so we say it's 0.9. And then 0.945, 100 is this. So say this is 0.95. Since 5 is between 5 and 9, we just add 1 from 5 to 4, and then this becomes 0. Right, so E is 0.493. So your nearest whole number, that's 0, because this 4 is not between 5 and 9, so we cannot add 1 from 4 to 0, so it's a 0 to your nearest whole number. And then so your nearest 10th, remember this is the 10th part, so we say this is 0.5, because 9 falls between 5 and 9, so add 1 from 9 to this, so it becomes 0.5. And then to the nearest 100th, that's have the 100th part here. And of course 3 is not between 5 and 9, so we cannot round up. So say to the nearest 100 is 0.49. Okay, so for F now, F is 9.507. So to your nearest whole number, that is 10, because 5 after the whole number is between 5 and 9. So we take 1 from 5, add it to 9, becomes 10. And then 9.507. So this is the 10th place here. So this will be 9.5. Remember, 0 is not between 5 and 9, so we kind of add 1 from 0 to 5. So it's 9.5. And then to the nearest 100, there's the 100 place here. So that's what 9.51, because 7 after this digit is between 5 and 9. So you add 1 here, so that's 9.51. Alright guys, so that's it with rounding off numbers in exercise 2I. To the nearest, we learned how to round off numbers to the nearest 1000, nearest 100, nearest 10. We also learned how to round off numbers to the nearest whole number, nearest 10th, and nearest 100th. So we'll move on to the next exercise, which is exercise 2J. Moving on to exercise 2G, it says round off these numbers to the nearest 1 significant figure, 2 significant figure, and 3 significant figure. Okay, so we start with the first question, which is A. And let's go over to a whiteboard, Microsoft Whiteboard, to see how we can solve these questions. Okay, so exercise 2J. Round off actually it's a bit blurry, so I'm just going to increase this to 100. Okay, so round off these numbers to 1 significant figure, 2 significant figures, and 3 significant figures. So the first one is 7,284. Okay, so in rounding off significant figures, we move from left to right when we're counting. Okay, and then for numbers between 5 and 9, we round up, and for numbers between 1 and 4, we round down. Okay, so let's see how we can round up this number to 1 significant figure, 2 significant figures, and 3 significant figures. So it's pretty easy, just follow as I demonstrate. So 7,284 to 1 significant figure. Alright, so how do we round this off to 1 significant figure? So of course the number is 7,284. Now remember, we count from left to right. So we're going to start from the left, and the first number, that is 1, is 7. The first significant figure is 7. So that's the first non-zero digits, right? So in rounding off numbers to significant figures, we start counting from left, from the first non-zero digits. Okay, start counting from the from the left. So the first non-zero digit from the left, which is 7 here. Okay, and to round this off to one significant figure, we look at the digit next to 7. So is this digit next to 7 between 5 and 9? It's not between 5 and 9, so we cannot add 1 from 2 to 7. Okay, so we simply round this 2 down and all the other digits after it. So we see that 7,284 to one significant figure is 7,000. And then for the second one, we start from left to the right, right? And then remember counting from the first non-zero digits. So this is 1, 2, so 2 here. And then we look at the digit after 2. So is 8 between 5 and 9? It is. So we have to round up. And then we add 1 from 8 to 2. So that gives us 7,300. And of course, every other digit after 8 becomes 0, including 8. And for 3 significant figures, remember from left to right, that's 1, 2, 3. So we're concerned with 8 here. And then we look at the digits after 8, which is 4. So is it between 5 and 9? No, so we cannot round up. And we cannot add 1 to 8. So we say that 7,284 to 3 significant figures is 7,218. Okay, so let's look at the second question, which is 6,035. So it's one significant figure, just like we did the first one. Remember, left to right. All right. So the first significant figure is 6. Digit after it is 0. So we cannot round up 0 because it's not between 5 and 9. So and we cannot add 1 to 6 as well. So we say it is 6,000, and all the other digits after 0 become 0 too. Okay, and then for 2 significant figures, 1, 2, the second digit is 0, digit after 0 is 3. 3 is not between 5 and 9, so we cannot round up. So 3 becomes 0, and the digit after it becomes 0 as well. So it's going to be 6. It's going to be 6,000. And then for 3, to round this up to 3 significant figures, the third digit here is 3. So 5, of course, after 3 is between 5 and 9. So we round up and add 1 to 3, so it becomes 6,014. And the C question, or question C, is 14,612. So, of course, the first digit is 1, and then after 1 is 4. 4 is in between 5 and 9, so we cannot round up, so it becomes 10,000. And then for question 2, which is to round up to 2 significant figures, the second digit is 4. Digit after 4 is 6. 6 is between 5 and 9, so we can round up and add 1 to 4 to make it 15. And then, of course, 6 is 0, and then the others become 0 as well after 6. So question 3, 3 significant figures, third digit is 6. Okay, and after 6 we have 1, and then since 1 of course is in between 5 and 9, we're going to round down. Okay, so it's going to be 4,600. Okay, so just a quick recap of what we did, quick demonstration. I'm going to use the first example. That's 7,284. So you're rounding up to 7. You're rounding up 7, rounding off 7,284 to one significant figure. What we did was we considered. Remember, we're going from left to right, looking at our significant figures starting from left to right. So the first significant figure here is 7, right? And then after 7, after 7 is 2. Okay, 2 isn't between 5 and 9, so we don't round up. Okay, and we don't add 1 to 7, so we round down. Two becomes 0. And the digits after it. After 2 becomes 0. So that's how we did question A and B and C. So we'll just move on with the same method, same procedure as we've done with B and A, B, and C. So we'll move to D. Okay, so D is 3604I. Okay, so to one significant figure, that's 4,000. So two significant figure, remember, same as we did with the previous examples, the first digit here, since what we're doing here is to round up to one significant figure, so we're looking, the digit that we're concerned with is the first digit, which is 3, and then the digit after 3 is 6, and 6 is between 5 and 9. So we round up, take 1, add it to 3, it becomes 4,000, and then 6 goes to 0, and the digits after it go to 0 as well. And then for two significant figures, 1, 2, so we're concerned with 6 here, and then the digit after 6 is 0, it is not between 5 and 9, so we cannot round up, so it becomes 3,600. And then for three significant figures, the third digit here is 0, and digit after 0 is 4, so we have to round down because it's not between 5 and 9, of course, so this becomes 3,600 as well. So three significant figures. Okay, so for E is 8,009. 8,009. So it's round up to one significant figure. Remember, first digit from the left is 8, and digit after 8 is 0, right? 0 is in between 5 and 9, so we can't round up. So it's going to be 8,000, so one significant figure. And then for two significant figures, second digits from the left is 0, and digit after 0 is 0, of course, and we can't round up, so it's going to be 8,000. 8,000. And for 3, third digit is 0, digit after that is 9 to round up, so it's going to be 8,010. 8,010. 8,010. So for F, that's 5,050. So first digit is 5, digit after that is 0. So to one significant figure, this is 5,000. So for second digit is 0, digit after that is 5, so we're going to round up, so it becomes 5,100. For 3, digit after, we're concerned with 5, that's the third digit, digit after that is 0, so it's going to be 5,550, so 3 significant figures. Okay, so let's clear the whiteboard so we can make space for the next questions. So I'm going to write exercise 2G. Continued. And G, that's 28,336. So remember, 1 is to one significant figure, 2 is to 2 significant figures, and 3 is to 3 significant figures. Okay, so to one significant figure, of course, the first digit is 2. After 2 is 8, so we round up, and then this becomes 3. All the other digits become 0. And then for 2, second digit is 8. After 8 is 3. It's not between 5 and 9, so we round down, so it becomes 28,000. Okay, so for 3, remember we're going from left to right, right? 1, 2, 3. So third digit is 3. After 3 is another 3. So we kind of round up, so it becomes 28,300. And for H, what do we have with H? H is 9,852. So to one significant figure, that's 10,000. Because the first digit is 9, we take 1 from 8, so add it to 9 becomes 10, and then the rest becomes 0. For the second one, 1, 2, we're concerned with the 8 here, and then the digit after 8 is 5. 5 happens to be between 5 and 9, with 5 and 9 inclusive. So we round up, and then add 1 to 8, so that becomes 9,900. Okay, and then with the third one, that's 3 significant figures. Third digit is 5. We cannot round up 2, so it becomes 9,850. For I is 9,395. Okay, so the first digit is 9, of course, and after that is 3. So, of course, we cannot round up, so it becomes 9,000. So 2, just gonna write this down here. 2, so significant figures, remember. Second digit is 3, digit after 3 is 9. So we round up, so it's going to be 9,400. So 3 significant figures, third digit is 9. Okay, and after that is 5. So we take 1 from 5, add it to 9. So this becomes 9,400 as well. Because 1 added to 9 is 10, and then you add the 1 plus 3, so that's 9,400. Don't be like, since adding 1 to 9 is 10, you shouldn't say that it becomes 9,310. No. You just simply add the extra 1 to 3, so it becomes 9,400. Okay, so don't make that mistake. Okay, so we're just going to draw a line to do the next 3 questions. So J is 26,002. So it's one significant figure, that's 30,000. Hope you guys are following. So 2 significant figures, it is 26,000. Okay. 3 significant figures, it is 26,000 as well. And for K, 69,625. 1 significant figure, it is 70,000. 2 significant figures, it is 70,000 again. And to 3 significant figures, it is 69,600. Okay. And for L is 19,314. So 1 significant figure, it is 20,000. So 2 significant figures, it is 19,000. So 3 significant figures, it is 19,300. 19,300. Alright, so that's it for the first part. Let's see what the second part is all about. Okay, so the second part says round up these numbers to the nearest 1 significant figure, 2 significant figure, 3 significant figure, and 4 significant figure. Oh, okay, so let's see how we can do this, right? Okay, so let's go back to our Microsoft whiteboard and see how we can solve these questions. Okay, so I'm just going to clear this. So remember, once you get the hang of it, it becomes really easy and you can just do it without having to write anything on paper. Okay, so this is question 2. Round off to 1 significant figure, 2 significant figure, 3 significant figure, and 4 significant figure. Okay, so question 2, that is, the first one is A, which is 7.0384. Okay, so how do we do this? Now remember, like we did before, we said counting significant figures goes from left to right. Yes? Goes from left to right. So the first significant figure here is 7, and after 7 is 0. Of course, so 0 is in between 5 and 9, so this to 1 significant figure is 7 points. All the zeros, right? 0, 0, 0, because after this 0, after rounding down the 0 to 0, the rest of it becomes 0 as well. So this is 7 to 1 significant figure. Okay? And B, approximately 7 to 1 significant figure. And okay, so that's not B, that's 2. So this is 1, and this is 2. So here with 2, we're rounding off to a significant figure. So second is 0, of course, and then after 0 is 3. So it's going to be 7.0. Right? So for 3, of course it's 7.0 because this is 3. We cannot round up. We cannot add 1 to 0 here. So this still remains 0. And then after the rest, after 0, 3, 4 become 0. So it's going to be 7.0. Okay, so 3. So 3 significant figures is so this is 1, 2, 3. And after 3 is 8. So of course we can round up. So it becomes 7.04. Okay. And then to 4 significant figure. So after, that's 1, 2, 3, 4. Okay. So after 8 is 4, and we cannot round up. So it becomes 7.038. 7.038. 7.038. That's the answer. So the next one, which is B, is 18.502. Not 18.502, 18.502. It's important to pronounce it, or to enunciate it that way, 18.502, or to say it that way. Okay, 18.502. Right, so one significant figure, of course, this is 1. That's, remember, from left to right. So the first is 1. After that 1 is 8. So we just take 1 from 8 to make this 2. 0. Okay. And then after 1, everything else becomes 0. So it's 20. And then 2 significant figures. So 1, 2, that's 8 here. And after 8 is 5. So we take 1 from 5. So it becomes 19. Take 1 from 5, add it to 8, becomes 9. So that's how it's 19. So to 3 significant figures, so 1, 2, 3, that's 5. So it becomes 18.5. And then to 4 significant figures, this is 1, 2, 3, 4. So after 0 is 2, of course you kind of round up 2. So it's 18.50. So C is 12.675. So it's 1 significant figure, that's 10. So significant figure, that's 13. Then for 3 significant figures, remember 1, 2, 3. So it's going to be 12.7. And then to 4 significant figures, remember 1, 2, 3, 4. That's 12.68. Okay. So we'll draw a line here for D to F. That's on neatly. D. Now D is 3.7798. 1 significant figure, that's 4. So significant figure, that's 1, so that's 3.8. Three significant figure, that's 3.78. And then 4 significant figure, that's 3.78 as well. Because you take 1 from here to 9 becomes 10, so you have to add 1 from the 10 to this. So on the 1 0 actually, so this is 8. Okay, so it's 3.9, 3.78, 3.7. This is 7, 8, 3.78. Okay, so E 3.780. Okay, that's 4 significant figures. Yeah. So on E is 234.06. So I, the first one is 2, so that's 200. Second, that's 213. 3 significant figures, that's 2, 3, 4. And I'm just going to write it here. 4 significant figures, that's 3, 4. That's 234.1. Okay. And then F, which is 79.405. For I, that's 18. That's 1 significant figure. For 2, that's 80 as well. No, that's 79, sorry. So for 2 significant figures, that's 1, 2. I'm concerned with 4 here. So we're going to, since 4 after. Alright, so for 2 significant figures, remember we go from left to right. So second digit here is 9, and then after 9 is 4. 4 is in up to 5, between 5 and 9. So we're going to round down, so it's going to be 79. 79, okay. And 3 significant figures, that's 1, 2, 3. Can be 79.4. And then for 4 significant figures, can be 79.41. Okay. So 79.41. All right. Let's see now. We're going to the next question, which is, that's after F. That's G, right? Okay, so we're continuing with exercise 2J. Of course, the instructions remain the same. Round off these numbers to one significant figure, two significant figures, three significant figures, and four significant figures. Okay, so we'll continue with, remember this is continuation. Let's write this out. Okay, so continue with question G, which is 62.469. So to one significant figure, this is 60. To two significant figures, this is 62. To three significant figures, this is 62.5. To four significant figures, this is 62.47. And then next one is H, which is 1.9942. Okay, 1.9942. Right, and then to one significant figure, that's 2, of course. To two significant figures, that's what? 2.0. To three significant figures, so three significant figures, that's 1.99. So four significant figures, that's 1.994. And the next is I. The other question is 780.88. Now to one significant figure, this is 800, right? So two significant figures, this is 780. To three significant figures, this is 781. To four significant figures, this is 780.9. And then the next is J. So just draw a line here. And for J, which is 678.45, that's 678.45. So it's one significant figure, that is 700. So two significant figures, that is 680. To three significant figures, that is 678. And then to four significant figures, that is 678.5. And then after J comes K. K is 25.205. To one significant figure, that is 13. To two significant figures, that is 25. To three significant figures, that is 25.2. And then to four significant figures, that is 25.21. And after K comes L, which is the last one for this part 2, for the part 2 of exercise 2J, that is 2.00567. So to one significant figure, that is 2. To two significant figures, that is 2.0. To three significant figures, that is 2.01. And to four significant figures, that is 2.006. Alright, so let's move to the third part, that is exercise 2J, the third part. Two significant figure and three significant figure. Okay, so A, which is 0.06752. Alright, so we start with A, and that's 0.06752. So the first one to one significant figure. Remember, what we're looking at is the first non-zero digits. Okay. Now this here is 0. It's not the first non-zero digit because it is 0. This here Another 0, of course, isn't the first non-zero digit because it is 0. But then 6 is the first non-zero digit because, of course, it is not 0. So it's one significant figure. This is 0.07, right? Because this is 7 after 6, and it's between 5 and 9. So we round up, and then becomes 0.07. So the second digit is the second part of the question, which is to round up to two significant figures, is 0. Remember, 1, 2, right, from the first non-zero digits. So 0.06. Okay. After 7 is 5. 5 is between 5 and 9. 5 and 9 inclusive. So you add 1, so 7 here becomes 8, and then the rest becomes 0. So third one, 3 significant figures. That's 5, right? So it's going to be 0.0675. Okay, B. Now B is 0.3059. Okay, so first non-zero digit, of course, is 3. So it's going to be 0.3. So 1 SF. So the second one, so 2 SF is 0.31. So 3 is what? 0.36. Okay. Then C is 0.006307. So, alright, so it's one significant figure. Remember, we're starting from the first non-zero digits. There's going to be 0.006. Okay. And for two significant figures, it's going to be 0.0063. For 3 significant figures, is going to be 0.00631. Okay. So we just draw a line here for D to F. So this D is 0.000666 and another 6. So of course, one significant figure, that's what now? 0.007. Two, that's 0.00067. Okay, so E is 0.03355. So this is 0.03. It's a significant figure, that's 0.034. Then 3 significant figure, that's 0.0336, right? So for F is 0.8804. So one significant figure, that's what now? 0.9. So significant figure, that's 0.88. And then 3, significant figure, that's 0.880. So for G, that's 0.002583. So to one significant figure, that's 0.003. Remember, we're starting from the first non-zero digit, which is this. So it's a significant figure, that's 0.0026. And then three significant figure, that's 0.00258. Okay. Now let's clear the whiteboard to make space for the next questions. Okay, so with H now. Okay, I'm just gonna write exercise 2J. This is a continuation of exercise 2J. Still part 3. Let's round off to one significant figure. Two significant figure. And three significant figure. Okay. So H now. 0.009009. So it's one significant figure. That's 0.009. So two significant figure, that's 0.0090. So three significant figure, that's 0.00901. Then after H comes Y, and 0.0002208. So one significant figure, that's 0.0002. Two significant figures, that's 0.00022. So three significant figures, that's 0.000221. Right? Of course. Okay, and J is 0.9004. So one significant figure, that's 0.9. So two significant figure, that's 0.90. So three significant figures, that's 0.900. Okay, so I'm just going to draw a line here for the remaining questions. Okay, so after J comes K. K is 0.0, no, that's 0.6, right? 0.60606, right? So to one significant figure, that's what now? 0.6. So two significant figures, that's 0.61. So three significant figures, remember 1, 2, 3, that's 0.606. Okay, and then L 0.042429. Okay, so one significant figure, that's 0.04. Two significant figures, that's 0.042. And three significant figures, that's what now, 0.0424. Okay. Okay, so that's the question, the part 3 of exercise 2J. So let's go move on to the part 4. So just go to canvas to make space for part 4. So let's see what part 4 is. Okay, so part 4 is round off these numbers to the nearest 1 significant figure, 2 significant figure, and 3 significant figures. So that's okay. So let's see how we can do them. So round off. Sorry, I'm just going to write this. That's 2J. Okay, so A now, that's 25.25. Right, so how can we do this? So it's one significant figure, that's what now? That's 13. Two significant figures, that's 25, right? Two significant figures, that's 25.3. Next is 3.9006. No, 3.906. Right? 3.906. Okay. So it's one significant figure, that's 4. So two significant figure, that's 3.9. 3 is 3.91. 3.91. And then for C, is 168.8. One significant figure, that's 200. Two significant figure, that's 170. Three significant figure, that's 169. And okay, I think I can write D here. D, which is 0.7018, right? 0.7018. So one significant figure, that's 0.7. 0.70. So three significant figures is 0.702. Okay. I'm try a line here. For E, So one significant figure, that's 8, 0.0078. Okay, so for F now, F is 0.000387.5. One significant figure, that's 0.0004. Two significant figure, that's 0.000339. And three significant figure, that's 0.000388. That's 388. Alright, for G, that's 109.8. So one significant figure, that is what? That's 100. Okay. So significant figure, that's 110. And three significant figures, that's 110 as well. So H is 40.65. So one significant figure, that is 40. Two significant figure, that's 41. So three significant figure, that is 40.7. Okay, so clear the canvas. So I'm just going to clear the canvas for the next questions. Okay, so exercise 2J, of course, in part 4. Same instructions. So 1 SF, 2 SF, and 3 SF. Okay, so for I, that's 5.735. So one significant figure, that is 6. Two significant figure, that is 5.7. Three significant figure, that's 5.74. And J, there 0.008088. So one significant figure, that is 0.008. Two significant figure, that is 0.0081. So three significant figure, that is 0.00809. Okay, so the next one is K, which is 694.9. So it's one significant figure, that is 700. So significant figures, that is 690. Three significant figures, that is 695. And L 0.04745. So one significant figure, that is 0.0 actually 0.05. Yeah, 0.05. And to a significant figure, that is, remember, first non-zero digits, which is 4, and then since 7 after it is between 5 and 9, we add 1 to 4, that's 5, and then the rest from 0. So I think I wrote this 5 too far from it, right? So we're just going to put it here. Okay, so what's this? 0.04745. So to two significant figures, that's 0.047 and 3. That's 0.0475. Okay, so the next part, which should be the last part of exercise 2J, is question 5. So let's see what question 5 is all about. So these numbers have been rounded off. State the number of significant figures in each. Okay. All right. So let's see. Of course, this is an oral exercise, but then we'll just go to our Microsoft Whiteboard to explain how we have the number of significant figures in these numbers, right? Now remember, so I'm just going to write this exercise 2J, question 5. State the number of significant figures in each. Okay, now for A is 78. Remember, significant figures are non-zero digits counted from the left to right. So if we're counting non-zero digits of this number from the left to right, we have 1, 2. So you have how many significant figures here? You have 2 significant figures. And for B, we're counting for B is 5.65. We're counting the number of non-zero digits from left to right. It's going to be 1, 2, 3. So we have 3 significant figures here. And then for C, 0.003. Remember, non-zero digits from left to right. How many non-zero digits do we have here? That's 1 from left to right. So that's 1 significant figure. And for D, that's 295.4. How many? That's 4 significant figures. And then for E, 0.055. That's 2 significant figures. For F, for F, that's 10.5. So this is 3 significant figures. Okay. Now, so some of you will probably have skipped the 0 since we're counting number of non-zero digits. That will be wrong because we already have a non-zero digits before it. Okay, so we have to count it as 1, 2, 3. So after F comes G, and that's 0.044. So that's what now? 2 significant figures. And H, we have 39.9. That's 3 significant figures. For I, and J, okay. L, that's 3 significant figures. Okay. Alright, so that's all with exercise 2J. We did all the parts 1 to 5. So we're going to move on to the next exercise, which is exercise 2K. Okay, so this is exercise 2K, and the instruction says round up these numbers to 1 decimal place, 2 decimal places, and 3 decimal places. So let's see how we can do this. Move over to our Microsoft whiteboard. Okay, exercise 2K. The instruction is round up these numbers to 1 decimal place, 2 decimal places, and 3 decimal places. So now let's do the first question, which is 12.9348. Now, in rounding up to decimal places, what we do is that we count from the decimal point, from left to right. Now, starting from the decimal points, the first digit here is 9. Okay, so look at the next digit, which is 3. Since 3 is in between 5 to 9, we kind of round up. So it's going to be 12.9. Okay, and then the rest, of course, become 0, including 3. So this is approximately 12.9 to 1 decimal place. And then, so of course, this is 1. And then to 2 decimal places, 2 places of decimal. Remember, from the decimal points 1, 2. So it's going to be 12.9 watts. Remember, after the second place, we have 4. 4 is in between 5 and 9, so we cannot round up. So it's going to be 12.93. So the third one, 1, 2, 3. After the third place is 8. 8 is between 5 and 9, so we round up. It's going to be 12.935. Okay, and then the second one, 24.1177. Okay, so to 1 decimal place is going to be 24.1. 24.1. So 2 decimal places is going to be 24.12. to 3 decimal places is going to be 24.118. And then third question is 5.0725. So 1 decimal place is going to be 5.1. Remember, we're counting from left to right, but we're not keeping the 0 digits. We're including the 0 digits in counting from the decimal point from left to right. So this is the first one, and after 0 is 7. Since 7 is between 5 and 9, we add 1 to 0, and then the rest becomes 0, of course, so that's 5.1. So in rounding off to places of decimal, we're going to include the 0 digits in our counting, as against what we did when we were rounding off to significant figures, where we didn't count the non-zero digits. Where we didn't count the 0 digits, we only counted the non-zero digits. Okay, so for 2 places of decimal, or 2 decimal places, remember 1, 2, which is going to be 5.07, right? And then 3 places of decimal is going to be 5.073, right? 1, 2, 3. So after 2 comes 5. 5 is between 5 and 9, so we'll take 1, add it to 2, that's 3, and then round, and then this becomes 0. So the fourth, alright, so for question 4, that's 1.9375. So 1 place of decimal, remember from the decimal points, that's what we count. It's going to be 1.9, right? 2 places of decimal is going to be 1.94. 3 places of decimal is going to be 1.948. And then for 5, question 5 is 1.9875. So it's 1 place of decimal, it's going to be 2. So 2 places of decimal is going to be 1.99. So 3 decimal places is going to be 1.988. For 6, that's 0.5846. So 1 decimal place is going to be 0.6. So 2 places of decimal, 2 decimal places is going to be 0.58. So 3 places of decimal is going to be 0.585. And so 3 places of decimal is going to be, so for question 7, sorry, that's 0.0625. So 1 decimal place is going to be 0.1. So 2 decimal places is going to be 0.06. And so 3 decimal places it's going to be 0.062. Okay, so I just need to clear the whiteboard to make space for the next questions. Okay, so still exercise 2K. Can write continued. So we stopped at question 7. So now we're doing question 8. That's 0.0375. So for question 8, 0.0375 to 1 place of decimal is 0.0. So 2 places of decimals. I'm just gonna write this 1 dp into 2 dp. BP. For 3 is 3 BP. So this is 0.04. So 3 decimal places is 0.038. For 9, so 1 is 0.9 to 0.90, 3 0.900, and 10, question 10, 0.0089. So it's 1 decimal place is 0.0. So 2 decimal places is going to be 0.01. So 3 decimal places is going to be 0.009. So that's it, guys, with exercise 2K. Okay, guys, so we're done with exercise 2K. So the next is exercise 2L. Alright, so with exercise 2L, I'm going to be doing exercise 2L here. Now the first one, question 1, the A part says it will cost 3.18 billion to renovate the state's classroom. Okay, so we're to round this 3.18 billion to 2 significant figures and write it out in full. So remember, 3.18 to 2 significant figures is 3.2 billion. And if we're going to write that out in full, let's see how we can do that. Okay, so first of all, 3.18 billion to 2 significant figures is 3.2 billion naira. Okay, and then writing 3.2 billion in full, what we have is 3 billion and 200 million. Okay, the B parts down. The area of Ghana is 23.9 million hectares. Now, 23.9 million hectares into 2 significant figures is 24. It's 24 million hectares. Okay, so write that out in full. What we have is 24 million hectares. Okay, C, the estimated population of Lagos is in 2006 was about 16.06 million. So it's 2 significant figures. That is 16 million. Okay, 16.06 million to 2 significant figures is what? 16 million. And in full, it's a 16 million with 6 zeros like this. Okay, now D says 1 barrel of oil has a volume of 1.5899 times 10 to the power of minus 3 cubic meters. So it's 2 significant figures, that's 1.6 times 10 to the power of minus 1 cubic meters. So 1.5899 times 10 to the power of minus 1 cubic meters to two significant figures is 1.6 times 10 to the power minus 1 cubic meters. So in full, of course, that is 0.16 cubic meters. Okay, so we draw a line here for E. It says the light from the moon is 2.15 times 10 to the power minus 6 times the light from the sun. Okay, so let's see. Alright, 2.15 times 10 to the power minus 6. So two significant figures is 2.2 times 10 to the power minus 6. So if you write that out in full, you have 0.0000002 and 2. Yep. Okay. So for F, what is F? So F says the sun is about 1.496 times 10 to the power 8 kilometers from the Earth. So two significant figures is 1.5 times 10 to the power 8 kilometers. Now, if you want to write that out in full, it's going to be 150 million kilometers, right? And the second question, which is question 2, says for these statements, round each number to two significant figures, then write it in standard form. Okay, the budget of Oyo State was 892.46 billion naira. So to two significant figures, that will be 890 billion naira. So how do we write that out in full? Okay, question 2. 892.46 billion. So two significant figures is 890 billion. So if you want to write that out in full, it's going to be 890 . Oh, they didn't ask us to write that out in full, I'm sorry, they asked us to write it in standard form. Okay. So that's going to be 8.9 times 10 to the power of 11. So if you guys are confused about how to write this out in standard form, well, we know that a billion is, we know that 1 billion is 10 to the power of 9, right? So 890 billion is 890 times 10 to the power of 9, 890 billion. Okay, let me just write this out. $890 billion equals 890 times 10 to the power of 9. Okay, so if we Remember, in standard form, the A part, or this first part here, has to be between 1 and 10. So to make this between 1 and 10, we have to move the decimal point, which is here, 2 steps to this side. That's 1, 2. So it becomes 8.9 times 10 to the power of 2 times 10 to the power of 9. So that's 8.9 times 10 to the power of 2 plus 9, right? 10 to the power of 2 times 10 to the power of 9. So that's 8.9 times 10 to the power of 11. Okay, so that's just a quick way to do it in your head. All right, so question 3. Okay, so there's the B part of A. This is the A part. Now the B part says, in 2001, there were 995,008 orphans in Nigeria. Okay, so 995,000 to 2 significant figures is 9 is what? 1 million. Okay, 1 million. Now to express 1 million in standard form, it's going to be 1 times 10 to the power of 6. Okay, so let's move to the next question. Just C. Just going to clear this for space. Exercise 2L still. Now it's just 2C. So it says 28.5 or 28,500,000 pound worth of goods. 28,500,000 pounds worth of goods was imported from the UK. $28,500,000. So 2 significant figures is what? $29 million. So standard form is 29 times 10. It's 2.9, sorry. 2.9 times 10 to the power of 7. Now, same way we did with the 890 billion, you could just say 29 times 10 to the power of 6, because 1 million is 10 to the power of 6. And then you move the decimal point here again to make it between 1 and 10. So it's going to be 2.9 times 10 to the power of 1 times 10 to the power of 6, which is 2.9 times 10 to the power of 1 plus 6, which is 2.9 times 10 to the power of 7. So that's how we got 2.9 times 10 to the power of 7. Okay, pretty easy, right? So we move to 2D. 2D, yes. The density of air is 0.001293 grams per cubic centimeters. Of course, this is grams per cubic centimeters because of the -3. Okay, so when you guys do this in physics, you know that density is mass over volume. So this is grams per cubic centimeters. Right, so to express this to 2 significant figures, remember, when we're dealing with significant figures, we start with the first non-zero digits from the left. Okay, so this to 2 significant figures is 0.00113 grams per cubic centimeters. Okay, and then to express it in standard form, remember how we did with the previous ones, Remove the decimal 1, 2, 3. That's 1.3 times 10 to the power minus 3 grams per cubic centimeters. Okay, now 2E, right? So I'm going to draw a line, outline, 2E. The land area of Africa is 30,280,000 square kilometers. That's interesting. So two significant figures, because that's the instruction. Two significant figures, that is 30 million square kilometers. And if you want to change that standard form, that's 3 times 10 to the power of 7 square kilometers, which is the same way as what we did, just the same way we did this right here. So that's 2F. Now, 2F is 1 watt is equivalent to 0.001341 horsepower. 0.001341 horsepower. Okay, so the two significant figures is 0.0013 horsepower. Now, in standard form, it's what? 1, 2, 3. It's 1.3 times 10 to the power minus 3 horsepower. Alright, so that's for question 2. And for question 3 now, let's just clear the canvas to make space for question 3 and the other questions after it. So this is exercise 2L still. Continue. Question 3. So it says, in an election, there were 22.77 million registered male voters and 24.47 million registered female voters. How many voters were there altogether? Okay, so remember the instruction says round up. It says round up each number to two significant figures. So the first number to two significant figures is 23 million, right? And the second number to two significant figures is 24 million. So the sum of both of them is 47 million. So of course this is the answer. We have 47 million registered voters. Altogether. Now question 4. Just draw a line here. In successive years, the crude oil production in Nigeria was 7.580 times 10 to the power 9 barrels and 7.677 times 10 to the power 9 barrels. How many barrels were produced altogether in those 2 years? Okay, so it's a simple addition here, but of course, we're going to round off each numbers to two significant figures first. So the first one is 7.677 6 times 10 to the power of 9. And the second one is 7.7 times 10 to the power of 9. So if we add both of them, we have this will be 3, and this will be 15.3 times 10 to the power of 9 barrels all together. And then let's write it in standard form. Okay, so this will be 1.53 times 10 to the power of 1 times 10 to the power of 9, going to be 1.53 times 10 to the power of 10 barrels. Okay, it seems like we didn't remember to write 3 in standard form. So of course 47 million in standard form is 47 times 10 to the power of 6, and then this is 4.7 times 10 to the power of 7, okay, in standard form. Okay, so the next is question 5. I'm just going to clear this for question 5. Exercise 2L. Continuation. Question 5. Question 5 says the height of Mount Everest is 8.85 times 10 to the power of 3 meters. The height of Mount Kilimanjaro is 5.89 times 10 to the power of 3 meters. Write these heights in ordinary form and find the difference in height between the two mountains. Okay, so if we're going to write 8.85 times 10 to the power of 3, 5.89 times 10 to the power of 3 in ordinary form, let's see how we can do that. Now remember how we did it in the previous exercises. So simply write zeros out and then move the decimal points 3 steps to this side, to the right here. That's 1, 2, 3. When we stop here, that's where our new decimal point will be. So 8.8. So let's write this 8 out clearly. So 8.85 times 10 to the power of 3 meters is 8,850 meters. And then for 5.89 times 10 to the power of 3, we're going to do the same thing. We're going to move 1, 2, 3. So 5.89 times 10 to the power of 3 meters is equal to 5,890 meters. Now they said find the difference in height between both mountains. Okay, so the difference in height is going to be 8,850 minus 5,890. Okay, so that's going to be what now? 2,960 meters. Of course, this is meter. So this is the answer. And then if we were to write this in standard form, of course, this will be 2960 meter in standard form. Will be 2.96 times 10 to the power 3 meter. Okay, so question 6. Question 6. Question 6 says, in 1920, the population of the world was 1.8 billion. By 2000, the world's population was 6 billion. Find the increase in the world's population, during those 80 years. Okay, 1.8 billion in 1920 and 6 billion in 2000. Okay, so the increase is, of course, 6 billion minus 1.8 billion. Okay. So 6.0, we did like this, 6.0 billion minus, okay, so it's just simple, that's 4.2 billion. If that was difficult for you, it's just really simple. You take 1 from 6, it becomes 10, this is 5, 10 minus 8 is 2, 5 minus 1 is 4, 4.2 billion. In standard form, that's 4.2 times 10 to the power of 9. Okay, and 7, okay, this is in standard form, right? In standard form. Now, for question 7, it says in 2007, the population of Nigeria was 140 million. By 2012, the population was 170 million. What is the increase in Nigeria's population during these 5 years? So the increase is simply 170.1 million minus 140 million. And that is 30.1 million, which is equal to 3.01 times 10 to the power of 7 in standard form. So this is the A part. So let's clear the whiteboard to make space for the B parts, right? So it's 2L. Continued 7B. Now, express the increase in standard form to one significant figure. So remember, the increase that we got was 3.01 times 10 to the power of 7. Now, to express it, so this to one significant figure, of course, is already in standard form, is 3 times 10 to the power of 7. So that's the answer. So question 8. Question 8 says, the area of Liberia is approximately 10 times the area of the Gambia. If the area of the Gambia is approximately 1.1 times 10 to the power of 4 square kilometers, find the approximate area of Liberia. Okay, let's see now. So I just write out the facts. Area of Liberia is approximately 10 times the area of the Gambia. Okay. And area of Gambia is approximately 1.1 times 10 to the power of 4 square kilometers. So what is the area of Liberia? So the area of Liberia will be 10 times 1.1 times 10 to the power of 4 square kilometers, which is 1.1 times 10 times 10 to the power of 4 square kilometers. This is 1.1 times 10 to the power of 1 plus 4 square kilometers. 1.1 times 10 to the power of 5 square kilometers. Okay. Yeah. Now that's the answer. So question 9. See how we can do question 9. Question 9 says the distance between 2 points is 2.54 times 10 to the power of minus 2 meters. Express this distance in kilometers in standard form. Okay, now we know that 1 meter is equal to 1 over 1,000 kilometers, right? So if 1 meter is equal to 1 over 1,000 kilometers, then 2.54 times 10 to the power of minus 2 meters is 2.54 times 10 to the power of minus 2 times 1 over 1,000 kilometer. And this is 2.54 times 10 to the power of minus 2 times 1 over 10 to the power of 3 kilometers, right? Which is 2.54 times 10 to the power of minus 2 times 10 to the power of minus 3. Remember from the law of indices that we learned in the previous exercises, 1 over 1,000 or 1 over 10 to the power of 3 is the same thing as 10 to the power of minus 3. And then also from our law of indices, we have that 10 to the power of minus 2 times 10 to the power of minus 3 is 10 to the power of minus 2 plus minus 3, right? So this is 2.54 times 10 to the power of minus 2 minus 3 kilometers. This is 2.54 times 10 to the power of minus 5 kilometers. Now, if this was confusing, Okay, there's another way to do it. So I'm just going to erase this question 8 here. So if it was confusing from this point, we could have said 2.54 times 10 to the power minus 2 times 1 over 10 to over 1000 kilometers is 2.54 times 1 over 10 squared, right? Times 1 over 1000 kilometers. And 2.54 times 1 over 10 squared is 2.54 times 1 over 100 times 1 over 1000 kilometers. Okay, and of course this is the same thing as 100 times 1000. That's the same thing as 1 over 100,000 kilometers, which is equal to 2.54 over 100,000 kilometers is also equal to 2.54 over 10 to the power 5 kilometers, which is also equal to 2.54 times 10 to the power minus 5 kilometers. Okay, so that's the answer, same as we got here. Alright, so the next question is question 10, and it says, the pages of a book are numbered 1 to 300. A says, how many thicknesses of paper makes 300 pages? And B says, if the thickness of the book is 15 millimeters, calculate the thickness of one leaf, give your answers in meters in standard form. Right, so let's move over to our Microsoft whiteboard to see how we can do this. Okay, so I'm just going to write exercise. Okay, so I'm just going to write exercise 2L, continuation, and this is question 10. Okay, so we're going to have to do some thinking here, right? So we know that for a book, the pages of a book appear on the front of the paper and overleaf on the back of the paper, meaning that one leaf of the book, or one thickness of paper of the book, carries 2 pages, the front and the back, right? So say if one thickness of paper makes 2 pages, then half, this is 1 over 2, or half the thickness of paper makes 1 page. Okay, it's simple mathematics, right? If you have one thickness of paper making 2 pages, then half thickness of paper will be 1 over 2. Okay, so if half thickness of paper if half thickness of paper make 1 page, Right, so we're just going to write exercise 2. Right, so we're just going to write exercise 2L. Continue. And this is a continuation of exercise 2L, and this is question 10. So we're just going to do a little bit of thinking here, right? So we know that typically in a book, one thickness of paper makes 2 pages. That is the front and overleaf, that's the back of the paper or the leaf. So you have 1 page at the front, and then at the back you have the second page or the following page. So the preceding page on the front, and then the back of the paper, on the back of the leaf, you have the following page. So you have 2 pages for 1 thickness of paper. Okay, so let's say if 1 thickness of paper makes 2 pages, then half thickness of paper make 1 page. Alright, so this is exercise 2L. So there's a continuation, right? It's question 10. Right, so to answer question 10, we're going to do a little bit of thinking here. Now, we know that typically in a book, 1 thickness of paper or 1 leaf represents or makes 2 pages. You have the front page, and then overleaf, you have another page on the back. Right? So if 1 leaf or 1 thickness of paper makes 2 pages, then it means that half thickness of paper or 1 page is represented in half thickness of paper. Okay, so we're doing this so we can find how many thicknesses of paper or how many leaves makes 300 pages. Okay, so I'm just going to write this out for the sake of our calculation. So 1 thickness of paper makes 2 pages, then half thickness of paper makes 1 page. Okay, then this is right. Then if half thickness of paper makes 1 page, okay, then 300 times 1 over 2 thicknesses of paper makes 300 pages, right? So if half thickness of paper makes 1 page, then 300 times 1 over 2 thicknesses of paper makes 300 pages. And this 300 times 1 over 2 is 150. So 150 thicknesses of paper make 300 pages. Okay, so this is the A parts. Now to the B parts. Let's draw a line here for the B parts. Okay. Now the B part says, if the thickness of the book is 15 millimeters, calculate the thickness of one leaf. Give your answers in meters and in standard form. Okay. So the thickness of the entire book is 15 millimeters. Then the thickness of one will simply be 15 millimeters divided by 150 thicknesses of paper of 150 leaves. Of course, we know that one thickness of paper is equivalent to one leaf, right? So to find the thickness of one leaf will be the thickness of the entire book divided by the number of leaves that the book has, which is 150, as we have calculated in A. Okay, so let's just write what we're required to do. We're to calculate the thickness of one leaf in meters in standard form. Okay, so we know that 1 millimeter is equal to 1 over 1000 meter, which is equal to 1 over 10 to the power of 3 meter, right? And then we can convert the thickness of the book to meters by saying that thickness of the book is equal to 15 times 1, this is times, and write this out clearly, 15 times 1 over 1000 meter, okay, which is 15 over 1000 meter. Right, so now let's find the thickness of one leaf. Now we should note that one thickness of paper is equivalent to one leaf. Okay, so the thickness of one leaf is equal to thickness of the whole book over the number of leaves. Okay, so we have that number of leaves A, remember our calculation A is 115. Alright, so thickness of one leaf. Okay, maybe I should just go up, right? Go up a little bit. Okay, so thickness of one leaf is equal to thickness of book, which is 15 over 1000 meter, divided by number of leaves, which is 150. Okay, remember, thickness of the book is 15 over 1000 meters, right? As we calculated. So to do this, this is 15 over 1000 meter times 1 over 150, which is 15 over 1000 times 150. Let's write this clearly. 150. Okay, so 15 goes here 1, 15 goes here 10. So that's 1 over 1000 times 10, which is 1 over 10,000. I'm going to write this out clearly. 10,000. Right, which is 1 over 10 to the power of 4. I remember from our laws of indices, this is 10 to the power of minus 4. And then in standard form, it is 1 times 10 to the power of minus 4. Right? Remember, this part in standard form notation must be between 1 and 10. And of course, you have 10 and the index. Okay, so that's the answer to question 10 and the end of exercise 2L. Oh, of course, and this is in meters. Okay, this is in meters. So it's 1 times 10 to the power of minus 4 meters. Alright, so let's move to the revision test. Alright guys, so the revision test is what we'll be doing next, and it's got questions from numbering 1 to 10. So the first question says, the cloth curtain has an area of 1.2 square meters. Express this as a number of square millimeters. Okay, let's see how we can do this. Let's go to our Microsoft whiteboard. Right. Alright, so here in our Microsoft whiteboard, we're going to be looking at the questions in the revision test 2. Okay, that's for indices and standard form. Okay, question 1. So we're told that the cloth curtain has an area equals 1.2 square meters. Okay, so we're asked to express this area in square millimeters. So if we know the units of conversion, we know that 1 square meter, or let's just start from 1 meter. We know that 1 meter equals 1,000 millimeters. Therefore, if you square both sides, we know that 1 square meter equals 1,000 millimeter times 1,000 millimeter. So 1 square meter equals 1,000,000 square millimeters, or 10 to the power of 6 square millimeters. Okay, now since we know this, it will be easy for us to convert 1.2 square millimeters to square meters, 1.2 square meters to millimeters. Right, so 1.2 square meters to millimeters is equal to 1.2 times 10 to the power of 6 square millimeters. Okay, so let's do question 2. Question 2 says, simplify 4n squared times 7n. 4n squared times 7n. Okay, so moving on to question 2 now. Question 2 says, simplify 4n squared times 7n. Now, if you're a pro, you could just say 4 times 7, 28, n squared times n, that's n to the power of 3. Okay, but if you're still trying to get the hang of it, it might be best you just write it out like this: 4 times 7, collecting like terms. Okay, and n squared times n. 4 times 7 is 28 times n squared, 4 times n to the power of 2 plus 1 with our law of indices, right? So that's 28n to the power of 3. So this is 2a. Then the b part, let's see what the b part says. It says 6 times 10 to the power of 3 times 3 to the power times 3 times 10 to the power of 4. Okay, 6 times 10 to the power of 3 times 3 times 10 to the power of 4. Okay, just like we did before with the first one, we can collect like terms, so to speak. Okay, 6 times 3 is 18, and then 10, then this to the power of 3 plus 4, remember, and this is 18 times 10 to the power of 7. Okay, so we could express this in standard form as 1.8 times 10 to the power of 8. How do we do this? Remember, our decimal point is here after 8, so move it one step here, it becomes 1.8 times 10, and then 10 times 10 to the power of 7 is 10 to the power of 8. That's how we got this. Okay, I'll just write it. So I'm just going to write it out here. 1.8. Try to write this 8 clearly. 1.8 times 10 to the power of 1 times 10 to the power of 7. So that's, of course, 1.8 times 10 to the power of 8. Or you could express it in ordinary form. That's 18 to the power of 7. 18 times 10 to the power of 7 in ordinary form. Or 1.8 times 10 to the power of 8 in ordinary form. As remember the trick that we use. So you have your 1.8, you write as many zeros that is necessary after 8, and then you move the decimal because the index is 8, so you move the decimal 8 times this way. 1, 2, 3, 4, 5, 6, 7, 8. Stop here. Stop here with the decimal. So it is 1, 8, 0, 0, 0, 0, 0, 0, 0. Okay, so if we write out the right way, it's going to be 1, 180 million. So 1.8 times 10 to the power of 8 is 180 million. Okay, so that's 2b. Now let's move to 3, question 3. So just clear this. All right. Remember, still revision test 2, and we're doing question 3 now. Okay, so question 3 says, simplify a 20 a to the power of 8 divided by 5a to the power of 3, and then b 9 times 10 to the power of 6 divided by 2 times 10 to the power of 2. So let's see how we can work this out. So we can write it out like this. Let's start with a, of course. 20a to the power of 8 divided by 5a to the power of 3. This is equal to 20 over 5 times a to the power of 8 by a to the power of 3. 20 over 5 is 4, and this, of course, according to our law of indices, is a to the power of 8 minus 3, which is 4, times a to the power of 5, which is 4, a to the power of 5. And b, this is 9 times 10 to the power of 6. Okay, this looks rough, right? So I'm just gonna make it neat, right? Over 2 times 10 to the power of 2. This is 9 over 2 times 10 to the power of 6 over 10 to the power of 2. So 9 over 2 is what? 4.5. And times 10 to the power of 6 minus 2, which is 4.5 times 10 to the power of 4. Okay, so let's draw our line here for question 4. So question 4 says remove the negative indices and simplify. So a is 10 to the power of minus 5, and b is y to the power of 0 times y to the power of minus 7. So let's start with a now. 10 to the power of minus 5. So remember, 10 to the power of minus 5 is the same as 1 over 10 to the power of 5, which is 1 over 100,000, which is, or we can leave it like this, or we could say it's 0.00001, right? Alright, so b now b is y to the power of 0 times y to the power of minus 7. Now remember, what we learned in the course of our exercises was that any number or any variable or anything at all to the power of 0 is 1. So y to the power of 0 equals 1, right? So this is 1 times y to the power of minus 7, or 1 times 1 over y to the power of 7, which is equal to 1 over y to the power of 7. Okay, this looks simple, right? So that's the answer. So let's move to question 5. So we just clear this to make space for question 5. Of course, it's revision test 2. Question 5. Express these numbers. Express these numbers in standard form. 6,700,029 and 219. Okay, let's see how we can do that. B is 29. C is 2019. Okay, so let's begin with A. Now, how do we do this? Remember decimal points here. So we'll go this way: 1, 2, 3, 4, 5, 6, right? The decimal point here. So that's 6.7 times 10 to the power of 6. And for B, it's 29. Remember decimal points here. We go 1. That's 2.9 times 10 to the power of 1. And for C, it's 290. Remember decimal points here. We go 1, 2. That's 2.9 times 10 to the power of 2. Okay, this is 229. Look like an A, right? So I'm just going to write out clearly 29. Okay, so question 6 says, change these numbers to ordinary form. Change to ordinary form. So A is 8.4 times 10 to the power of 5. B is 6 times 10 to the power of 4. C is 6.3 times 10 to the power of 1. Okay, so this is 4. Okay, so with A, remember, you want to write as many zeros as you're allowed to write as many zeros as you like after 4, and then you move the decimal points 5 places to this side, right? It's 1, 2, 3, 4, 5, stop here. So 8.4 times 10 to the power of 5 equals 8. 40, this is 8, 8 here, 8, 4, this is 4, 4 here, 0, 0 here, and 0 here again, this 0 here, this 0 here, and then the point. So this is what? 840,000. Same thing with B. Is 4. So we also have as many zeros. And we go 1, 2, 3, 4. Stop here. So 6 times 10 to the power of 4 is 60,000, right? And then with C, that's 1. Okay, stop here. 6 times 10 to the power of 1 is 63. So let's look at 7. question 7. So it says express in standard form. Express in standard form. So the first is 0.0007, second is 0.8, and third is 0.0024. Okay, how can we do this now? Same as we've been doing. We go 1, 2, 3, 4, 5. So that's 7 times 10 to the power minus 5, right? 1, 1, 2, 3, 4, 5. Okay? And B, 0.8, you go 1, right? 1. So that's 8 times 10 to the power minus 1. And so you go 1, 2, 3. That's 2.4 times 10 to the power minus 3. Okay, so question 8. Change these numbers to decimal fraction. Let's see. 6 times 10 to the power minus 4, 4.8 times 10 to the power minus 2, and 1.7 times 10 to the power minus 1. Okay, so that's 6 times 10 to the power minus 4, 4.8 times 10 to the power minus 2, and C is 1.7 times 10 to the power minus 1. Right, so for A now, 6 times 10 to the power minus 4, let's see. A is, remember we're counting left, right? Because we have the negative index, right? Okay, so we write as many zeros as we like before 6. To a reasonable extent, of course, bearing in mind what the index is. You know, we have the decimal points after 6, right? So move 1, 2, 3, 4. So we'll stop here. Decimal points here. So 6 times 10 to the power minus 4 is equal to 0.0006. And then B, 4.8 times 10 to the power minus 2. So, of course, write as many zeros. 4.8. We go 1, 2, stop here. And 0.048. And let's see. Oh, 1. Okay, so that's decimal points here now. That's 0.17. Okay, so remember, number of zeros you write before the number doesn't matter. All you just need to do is to write number of zeros to a reasonable extent so that you're able to count all the you're able to move the decimal points the number of times indicated by the index. Okay, so that's what matters. All right, question 9. All right, so for question 9, all right, so first question is to round off 8,348 to three significant figures. Okay, so that will be 8,350. Remember, we're counting non-zero digits from left to right. That's 1, 1, 2, 3. So we're going to, and then since after 4 we have 8, which is between 5 and 9. So we round up, so 4 becomes 5 and this becomes 0. And then the next one is B, which is 0.00796. Okay, so this is A, and then B zero point 0.00796. So that's round B to two significant figures. That's a round of B to two significant figures. Okay, so to two significant figures. Is 0.0080. Okay, and then C .329 to one decimal place. 6.329 to one decimal place. Okay, so remember we're counting from left to right after the decimal point. So this is 1 here, and after this is the first decimal place here, and after that is 2. So 6.329 to one decimal place is 6.3. And then D is 0.05684 to three decimal places. 0.05684. So three decimal places. Okay, so that will be 0 points. So 0, of course. 0.057. That's 1, 2, 3. So this after the third decimal place comes 8, so we round up, and then 6 becomes 7, and the rest of it goes to 0. Okay. So remember, for significant figures, we're counting the non-zero digits, but then when we're looking at decimal places, we include the 0 digits in our counting. So that is why this is 1, 2, 3. That's why I'll count it like that. Okay. So the next question is question 10. So let's see how we do question 10. Now question 10 says, in 2013, the estimated population of Nigeria was 176.3 million. If current birth rates stay the same, the population will rise to 440.4 million by 2050. What will be the increase in Nigeria's population during this time? Express this increase, or express the increase in standard form to two significant figures. Okay, so to get the increase will just be the difference between the two numbers, right? So let's see how I can do that. Okay, so it's question 10. A. The increase will be 444.4 million minus 173.6 million, which is 266.8 million. Okay, and then the B part, 266.8 million. So two significant figures is 217 million. So that's the end of our session on indices in standard form. We did all the exercises in our textbook of reference, the New General Mathematics for Junior Secondary Schools Book 2. We did all the exercises in the second chapter titled Indices and Standard Form. We learned some rules of indices, we learned how to write numbers in standard form, and how to change from standard form back to ordinary numbers. Okay, we also learned how to round up numbers to 1, 2, 3, 4, and so on significant figures, and how to round up numbers to 1, 2, 3, and so on places of decimal. So please feel free to leave your suggestions, questions, and comments in the comment section. I hope this was very helpful. Also, I would love for you to subscribe to the channel and like the videos, of course. So thank you so much for watching. Thank you. And please be sure to check out my other videos. Thanks again.